Hey everyone, if you're planning to improve your skills in developing agentic AI projects, or maybe if you even haven't started and you're planning to start learning how to develop agentic AI projects, especially in Python, this video is for you. And not only this video, I have a whole playlist of videos on YouTube for developing agentic AI projects from the very beginning to the end. And in all of my videos, I will never ever present a pre-written piece of code and just talk over it. I will do everything from scratch. I will create a new file, an empty file, and I will start to write each and every line of code. So we will experience the details, the errors, how to address them, how to add new features to our project, how to make a simple UI web application for our projects. We'll experience all of that and all the details involved in these different steps together. And as the saying goes, the devil is in the detail. So let's do it together. By the end of this video, you'll have learned to develop an application where 3 LLM agents, a host, a supporter, and a critic debate on any topic of your choice. We'll also create a slick user interface to showcase their discussion. Okay, so we'll be developing this project in two parts. Initially, we will develop the backend side, and afterwards, after we have a completely working backend, we'll start developing the front-end side. And for the backend, we'll be using the most recent version of AutoGen, which is 0.5. And for the front end, we'll be using Streamlit to be able to quickly develop a web application that visualizes the chats between the agents. So let's take a look at the AutoGen's documentation. AutoGen documentation. It was about a week ago that AutoGen released its most recent version, version 0.5.1, which is a stable version. And, well, AutoGen is a whole framework under which there are some sub-frameworks. And we have a core framework. This core framework is the low-level version, which handles the operations needed for dealing with LLMs and the messages and some of the low-level operations. And then we have the Agent Chat framework, which is built on top of the core, and it facilitates the development of agentic projects. You can see the codes are pretty readable and straightforward. It has a good documentation, I can say. It has both a tutorial and a section for more advanced topics. And, we have some concepts. You should try to master these concepts. The models, the messages, the agents, teams, human in the loop, termination, and managing state. And today in this project, we'll be working with the models, the messages, the agents, the teams, and the termination. And we will leave the human in the loop and managing state to the next videos. So one of the main topics in AutoGen is the agents, one of the main concepts. And we have an assistant agent. This class represents an LLM agent. It can also use tools if you want to do that. And as you see, it's pretty straightforward to define an assistant agent. We will specify some name. We should give it a model client, which is basically the underlying LLM. We can optionally grant it an access to some tools. And we can also specify the system message, which specifies the role of that agent. And to be able to define an agent, as you see, we need to define a model, an underlying LLM. And to define a model, we have this models concept. There are some classes for famous models, such as OpenAI, Ollama, and Gemini. So you can easily define an OpenAI LLM here. You see, you just need to import this class, OpenAI Chat Completion Client. And then you just need to define that LLM in one line and in one statement, and then you're good to go. Okay, so let's do that. From AutoGen extension.models.openai, import OpenAI Chat Completion Client. And now I can easily define a model, a chat completion client, and the model will be GPT-4o. and I need to declare my API key. So as usual, you have two options. First of all, please don't copy and paste your API key here. You can either have it in a separate file, and you should make sure that file isn't pushed to your GitHub repo and isn't public, or you can specify and you can define a system variable. So I can say for the API key, open api.text, read it and make sure there's no extra space in the end. So now I've defined my LLM, and to be able to work with this LLM, to be able to send it a prompt and get the result, I can use the create method. So this model has a create method. As the documentation suggests, it gets a messages, which is a sequence of LLM message. So I can easily say messages equals, well, it expects a sequence, so I can pass it a list. And well, one particular class for messages in AutoGen is the user message class. So as you can see in the documentation here, we can define a user message. We can import it from AutoGen core.models, and let's take a look at, let's import it from AutoGen core.models. Was it models? Yeah, import user message. And now I can define a user message. And as suggested by the documentation, it gets a content and source. So I would say content is, hi, how are you? And I should also define the source of this message. So I would say, that should be here. I would say source is user. And well, in the most recent version of AutoGen, there has been a huge focus on the async workflow. So, we can do programming usually in two different modes, in two practices. One of them is the synchronous mode, and the other one is the async mode. So if you're not familiar with those concepts, don't worry. I'm sure after this video, you have a good intuition. And of course, nothing stops you from going and searching and reading some tutorials about them. But to just roughly talk about it, we have a synchronous way of programming. And in synchronous way, each line is executed, and we will wait until that line is completely done. And after it's done, we will move to the next line. So this is, very roughly speaking, this is the synchronous way. And then we have an asynchronous way. For projects that have natural I/O bound, the program should wait for some outsider source to respond. So our project doesn't need to do a lot of processing, but should wait a lot. In these cases, and in more sophisticated projects, while waiting for example, the agent to respond from the OpenAI server, we can do other tasks that are not directly relevant and directly dependent on the current agent. So this helps us save a lot of time instead of waiting idle. So this is why, in most of the agentic projects, it's a very good idea to develop it with async mode. So we should import the async IO module from Python. And again, if you're not familiar with this library, don't worry about it. You will learn how to work to the extent that the agents can be functional. So for coroutines and for functions in async mode, instead of calling them like this, we should await them. And we should also define an event loop. And by an event loop, we'll see what I mean. So first of all, let's define a coroutine. A coroutine is a function in the async mode. So I would say async def main, and it has all these codes. And then here I will define the coroutine. So async io.run main. This means that I've created an event loop, And in the event loop, I'm running this coroutine. Okay, so now I'm awaiting model.create. So this means that I can send some prompt to the LLM to model, and I will get the response afterwards. And as the documentation suggests, it returns a create result object. We can also take a look at the create result object, but we can just print it now to see what it is. So this is the result, and I can just say print res Python debate. Okay, let's see. So as we can see here, the res or the create result object is a data class. It's in Pydantic way, or a data class in Python. It's a custom class to store some data, a structured way to store some data. We can get the finished response, the finished reason, the content of the result, and also how many tokens it was, and was it cached or not. And if we've asked for it, we can also get the log prop for each token. So if I want to print it more clearly, I can just say print res.content, and in this case we'll just see the response from the LLM. Hello, I'm just a program, so I don't have feelings, fair enough, but I'm here and ready to help. Okay, but we don't need to directly interact with the model. The agent will do that for us. So now we can define the agents, and for the agents I need to import the assistant agent class. So from AutoGen agent chat.agents import assistant agent. Now I need to define a supporter agent and the critic agent. So let's define the supporter. I would say supporter is an assistant agent. It should have a name. The name will be John, for example. And here's the system message. You are John, a supporter agent in a debate for the topic. And let's introduce topic as a variable so that we can easily change the topic later. And the topic will be, let's say, shall US government ban TikTok? And this will be our topic. You will be debating against, let's say, Jack, a critic agent. This is good enough, and let's clear this. And I should also specify the underlying model. So we have a model client, which is just the GPT-4o model I introduced earlier. And this will be the supporter agent. Now I will define the critic agent. And usually when I just want to mirror something else, and with some subtle changes, GitHub Copilot can suggest a clean piece of code, as you can see here. The name is Jack. Here's the system message. You are Jack, a critic agent in a debate for the topic. You will be debating against John, a supporter agent. And this will be the model client. So now I have the supporter and the critic agents, and it's time to create a team out of these two agents. So let's take a look at the team section of the documentation. By the way, this is a very good skill to be able to read documentation. If you have any questions from a module, it will be a very good skill to be able to read the documentation and find the answer for your question. So this really makes the difference between a professional programmer, a professional developer, and a so-so developer. So for the teams part, we have three options. We can have a round-robin group chat, we can have a selector group chat, or a magnetic one group chat. So today we'll be working with a round-robin. Let me just briefly talk about each of them. The round-robin group chat, as the documentation suggests, it's a team that runs a group chat with participants taking turns in a round-robin fashion. This means that we have a deterministic chat, and we know in in advance that which agent is going to talk when. So if we have two agents, a team of two agents, the first one talks first, then the second one, then the first one, then the second one, and the conversation goes on and on until we have until a condition is met and we terminate the chat or the maximum number of turns is reached. But the other two options, the selector group chat and the magnetic one group chat, these two are not deterministic. They're non-deterministic chat patterns. So we don't know in advance which agent is going to talk when. It depends on the context. It depends how the chat goes on. So we'll be working with the round robin today since we just have two agents and they're going to talk in a round robin fashion. And this is the documentation for the round robin group chat. We should import it from AutoGen agent chat.teams. And as you see, it takes a participant and a termination condition possibly and maximum number of turns in the group chat before stopping. Okay, so let me import it. I would say from AutoGen agent chat.teams import the round robin group chat. And let me introduce the team. It will be a round robin group chat and it will have the following participants: supporter and a critic. And for now, I will just specify the maximum number of turns, let's say 4. And that's it. Okay. Now I need to make the team start the conversation, start a debate. And for that matter, we have a run method. So I can say await team.run. And I should specify a task. So that will be, and what is this task? It will be, well, the documentation isn't that clear here, the task to run the team with. This will be actually the initial message that will be broadcast to the team. So I would say start the debate, for example, and it will return a task result, as you can see here. And just like the create result, a task result is another custom data class, and we can get the whole conversation once the team returns the task result. So I would say res equals await team.run, and then I would say let's print res Python debate. And now you'll see it will take a significant amount of time until we see the result. And this is a disadvantage of working with the run function. So while we're waiting, I encourage you to think about it. How can we mitigate this problem? How can we address this? Okay. Now you can see we have the whole chat. This is a task result object. It has a messages component. And the messages is a list of text messages. For each text message, we have the source and we have the content. So for example, this is the user's message, start the debate. And then we have John, the supporter. And thank you for the introduction. As a supporter of not banning TikTok in the United States, I believe it's crucial to emphasize the potential consequences and underlying issues and so on and so forth. And we have, dialogues from Jack and then from John, and then we've stopped the conversation. And this is a stop reason, maximum number of turns 4 reached. So I can print out the chat more clearly, and I can have a for loop for message in res.messages, and then I will say print. Initially I will print a bunch of dashes to make sure each dialogue is separated from its surrounding, and then I would say print message dot. You can see Copilot hallucinates in these contexts because these modules like AutoGen are pretty new and it hasn't been trained on these modules. So it tries to figure out by itself, and it almost always hallucinates in these situations. So just say, please never trust Copilot, and never just blindly accept what it is suggesting. So I want to print out the message that source, and then a colon, and then message.content. Yeah, this is right. Content. So let's run the code again. Now we should see a much more clear version. Okay, you can see here's the user message, here's John, here's Jack, again John, and then Jack. So we have a quite functioning backend side now. So the script works and the agents are engaging in the debate. But one particular problem now is that we should wait until the whole chat is done, the whole debate is over, and then we will print it out. So we would like it to work this way, that we can gradually print each dialogue once we have it, once it is ready. So to do this, the team has another method. It is called run stream, but it works quite different from the run method. So let me show you the run stream. We can say team.runStream, and indeed run stream is a generator. It's an async generator, as you see here. And if you don't know what is a generator, don't worry about it. I will talk about it momentarily, but I strongly encourage you to go after this video and read a little bit about generators. It's a very useful concept in programming. So generator is essentially a function, but instead of returning something, it yields something. And what is the difference? So in a regular function, whenever you call the function, it starts from the beginning of that function, from the initial line, and it goes on and goes on until it reaches a return statement, and then it returns something, and then everything is reset. So the next time you call that function, it will start over again, and it will run each line until it sees a return statement. But a generator is a function that has some sort of memory. So whenever you call it for the first time, it starts from the beginning. It goes on and goes on until it sees a yield statement. So it returns or yields that whatever is after yield, but it doesn't reset. It stays there. So the next time you call that generator again, it doesn't start all over from the beginning. It starts from where it left off. So it starts from the last yield statement and then goes on and on until it sees another yield statement. So as you see in this concept, a generator can be quite helpful, because once we have a response from an agent, we can yield it and we can stay there, and then we call it again and we have the response from the next agent, and then we call it again and then we have the response from the next agent. So this is how the generator idea can help us. So this is a generator, so we can call it several times, or we can even iterate over it. And since we're developing this part in async mode, we should use async for message in team.runStream. And this generator can return two types of objects. While the agents are working, it will return some messages, as we saw earlier here. It will return some text messages. This is its return type. But once all of the agents are done and the chat is over, the debate is over, it will return a task result object. So I should handle these two types of objects differently. I can say if message is an instance of task result, so if is instance message and task result, and I should also import the task result. So let me check where's the task result. You see we're in the round robin group chat, and round robin is a child of base group chat, and inside base group chat I can see the common methods. One of them is run and the other one is run stream, as we can see here. And inside run stream I can see it says that the return type is task result. And here it is. A task result is inside AutoGen Agent Chat.base. Okay, so from AutoGen Agent Chat.base, import task result. So if message is an instance of task result, I just want to print out the reason for stopping the debate. So print stopping reason and message.stopping reason. I guess it should be stop reason, not stopping. Let me check. Yeah, stop reason. So otherwise, I know that message will be a text message object, so I will just print the source and the content. And again, to make sure different messages are separated, I will have some dashes. And let me remove this part. Okay, let's run it again. Now I should gradually see the agent chats. You see, we're seeing user. Now we've seen John's response and now Jack's response. So instead of seeing all of the chat once the debate is over, now we can see, as the chat is in progress, the debate is progress, we can see the agent's results, the agent responses. And stopping reason now is that maximum number of turns, which is 4, has been reached. And to make it more natural, maybe it's a good idea to also introduce a host for the debate. So let me define a host. It will be another assistant agent. The name will be, let's say, Jane. Yeah, Jack, John, Jane. And I need to define its model client. It will be the model again. And this will be the system message. You are Jane, the host of a debate between a supporter agent, between John, a supporter agent, and Jack, a critic agent. You will moderate the debate. And then at the beginning of each round, so here's what I want. I want the host, I want Jane, to declare which round this is at the beginning of each round. And after maybe the third round, I want her to declare that the next round will be the final round, and then to terminate the conversation, the debate. So at the beginning of each round, announce the round number, and at the beginning of the third round, declare that it will be the last round or the final round. After the last round, thank the audience and exactly say terminate. Okay, so this is the system message for the host, and now I should also add the host to the team. Since I want the host to start the debate, I will add it here. So we have a host, we have a supporter, and we have a critic. And now let's specify some large number, maybe 20. So I can run the code and you can see the result. Of course, it will not terminate the chat after the fourth round. We'll see why, but it's a good idea to take a look at the debate now. Okay, now we can see Jane's dialogue. Welcome to the debate, everyone. Let's begin with round 1. John and Jack, are you ready? Let's dive into the topic at hand. The impact of technology on society. Oh, we forgot to pass the topic to the host. That's why it is hallucinating. So you are Jane, the host of a debate between John, a supporter agent, and a critic. You will moderate the debate, and then I would say the topic of the debate is topic. Yeah, this is right. now let's see. Welcome everyone to this engaging debate on the topic, shall the US government ban TikTok? Okay. And then we have John, which is supporting the idea, and we have Jack, which is a critic of the idea. And yeah, thank you, Jack. Now we enter round 3, which will be the last round. John, please proceed with your final remarks. And then we have John's comments, and then we have Jack's comments. And in the end, you see Jane has thanked the audiences, the participants, and we have terminate here, but the debate goes on and on. And that's because we haven't specified in our code to what condition will terminate the debate. So we need to do that as well. In the previous version of AutoGen, in version 0.2, we should have specified the termination condition for each agent, and we would have passed a callable function, a callable object, a function, or a lambda function. But in the new version, in 0.5 version, we should do that with the team. So I can say what is the termination condition. And for termination condition, we have a bunch of options. Let me show you. If you go to the termination page, so we have a lot of possible termination objects. You can see a termination condition, and that termination condition can be any of these conditions. For example, it can be an external termination. It can be a function call. So whenever a function is called, then the chat will be terminated. Or it can be for a text mention or a text message termination. So we'll be working with the text mention termination today. This means that whenever a specific expression or word is mentioned, it will terminate the chat. Or even whenever we have a text message, it will terminate the chat. But well, we just need to be vigilant for the terminate term. So we'll be using text mention termination. And we can import it from AutoGen agent chat.conditions. Let's import it. From AutoGen agent chat.conditions, import text mention termination. Okay. So the termination condition for the team will be a text mention termination object with the following text, which will be terminate. So from now on, whenever I have capital terminate in my chat, it will terminate the whole team and the whole chat. Let's run it again. Okay. Yeah, we can see that once Jane has declared terminate, the chat has been terminated. And here's the stopping reason: text terminate mentioned. Fair enough. And by the way, the chat is so interesting. You can read it and enjoy it. We can see convincing reasons from both sides, but you can run this code for yourself and read the reasoning. It's quite interesting, and I will definitely create some short videos from these debates. I guess it really worth it. Okay, so now we're done with the backend side. We have a fully functional backend. We're orchestrating the team, and we have an interesting debate between these two agents and our host. So now it's time to develop the UI and the front-end side. We'll be using Streamlit, and by the way, Streamlit has some visually appealing components, and it is usually used to quickly develop a prototype or a web application. So let me create an app.py. We can import it, import Streamlit as st. Initially, we should set a title for our web application. The title will be debate app, agents debate, or let's say agents debate. It's more interesting. And let's run it right now to see what we get. And to run an Streamlit app, you cannot say Python app.py. You should say Streamlit run app.py. Yeah, we have a quite empty page now with just the title. Let's go back. Now we need a text input to get the title. The topic of the debate. I can say topic will be st.text input. Enter the topic of the debate. And I can specify a default value for the topic. Shall US government ban TikTok? Yeah, this is good. So let's see what we have now. Yeah. Enter the topic of the debate. Shall US government ban TikTok? Good. And I need a button below the topic text input. So, and I want to see if the button has been clicked on or not. So I will use the clicked variable, and I will say st button, and the button label should be start. I can also specify a type for the button. It can be either primary, secondary, or other values. So let's say primary. This will make it prettier, at least to my eyes. And if the button is clicked, then I should orchestrate the team, the agents, and the debate should start. But for now, let's just, to see the logic, I want to just write debate start. So you see, this is the title, this is the topic, and once I click, it says debate start. Well, I should modify the debate a little bit so that I can use it inside my UI more effectively and more easily. So right now we have all of the backend code in one coroutine in main. And by the way, we have the topic as a variable here, but we're not, passing it to the main. It's hard-coded inside the main. So I want to split these into two coroutines. In the first coroutine, I will configure the team. And in the second coroutine, once I've configured it using the first one, I will orchestrate the team. And I will, make that coroutine to be an async generator. So in our UI, we can call it, we can iterate over it. And once we have a new message, we will display it as a chat. Okay, so I need to split this into two coroutines. Let me define a new one, async def team config, and it should get a topic. I just need to move all of these lines until the team definition inside the team config. You see? And of course, I don't need to specify topic here anymore. I can easily specify topic inside this part. So now I have a team config, and then I will rename this as debate. And in the debate, again, I need to get a topic, and I need to, let's pass the team to the debate. And once I have the team, then everything looks good for now. And then I will define my main coroutine. I'm just defining this one so that, this debate.py could be functional alone without needing to depend on the app.py. So here I would say topic will be this one. Team will be await team config with this topic, and then await debate team. Okay, this looks good, but I want it to work quite different. I want to turn this debate into an async generator. So for that purpose, I can, instead of printing this here, I can just say, I can define a message variable. So this will be, instead of printing it, I will say this is my message, and then I will yield the message. I will do the same for the else statement. Message will be this one, and I will yield the message. And now inside main, here's how I will make this debate work. I will iterate over this generator. I would say async for message in debate with this team, and print message. And I don't need to specify this, just print message. And I will print some dashes again to make sure dialogues are separated. So now the debate function, the debate script should be fine. It should work. Okay. Non-type object has no attribute run stream. Okay, it doesn't know the team. So I have the team here. Yeah. Inside this team config coroutine, I forgot to return the team. That's why it is none. Yeah, it's working now. Okay, now the only thing I need to do inside the app is to import these two coroutines from debate, import team config and debate. And now inside this if statement, if the button is clicked, I need to create the team. But since my backend is working in the async mode, I need to create an event loop here again. So I will define a coroutine here, async def main, just like my debate.py. And I would say team will be configure team with topic, and then I will iterate over the debates generator. And instead of, okay, I should show this to you before using it. Maybe it's a better idea. Streamlit has some elements for chat visualization. One of them is chat message. You can take a look here, sc.chat message. It takes a name and an avatar, which could be an emoji or an image or a pre-specified name like user or assistant or AI. And it will visualize each dialogue from an agent. So I need to define a container here, and initially it will be empty. So I will say, for example, chat will be st.container. And whenever the button is clicked, first of all, I will make sure that chat is clear, chat is empty. That way I can have several debates in my app in one run of the app. I don't need to close the app and run it again for the next debate. And then I would say with chat, I want to do it inside chat, and then let's move it here. Inside the chat container, I will iterate over the messages from the agents, and I would say we have three modes. We have three possible options. A message could be from Jane, it could be from John, or it could be from Jack, so I should handle them differently. So here I would say if message dot starts with starts with Jane, for example, because you see in my message template, I always have the name of the agent at the beginning. You see message.source. So if message.starts with Jane, then with st.chatMessage with the name of Jane and the avatar of, for the avatar, I will use a robot emoji, yeah, as suggested here. Then just write down the message, st.write message, and then elif message.starts with John, then with the chat message with the name of John, and I will use an avatar of thumbs up. You can either search for this avatar, or I have another trick. I will make this in the comment so that Copilot can suggest it to me. Thumbs up emoji. And now I expect Copilot to, yeah, it's suggested. And then I'm sure Copilot will figure this out. For Jack, it will use a thumbs down, yeah. So we have a thumb down here. And I guess we're good to go. Let's run the code. Oh, and I need to create the event loop now. So let's import the async IO. And here I will say async IO dot run the main coroutine. Okay, let's run the Streamlit app and see what happens. Oh, we have an error. Oh, what is this ent? Okay, let's run the code again. Okay, here's the application. Here's the topic. I will press start. And yeah, Jane is welcoming the audience. And we have John's dialogue. And then we have Jack's dialogue. And then we have Jane again. So you see it's working. Now we have a web application that visualizes the debate, the chat between the agents. And just for fun, I can do one more thing. I can also, you know, in the end, once everything is okay, I can say st.balloon. I guess it was written like this. Let's see. The balloon. Streamlit balloon. Yeah, st.balloons. It's right. So once the chat is over, I want to show some balloons coming down the screen. So this way I can figure it out that the chat is done. The debate is over. Yeah. Yay. So we've developed the backend and the front end side of this debate between two LLM agents with the host. You saw how easy it was using both the AutoGen and Streamlit. So I strongly encourage you to do this yourself. You can watch the video, but please, you need to develop it yourself from scratch without consulting the video. This is a really important skill to be able to start from scratch and, you know, do the coding. And once you have an error, you know, that is really okay, but you should be able to address that error. You should be able to solve it. So I recommend, please go ahead and do this yourself. And by the way, if you have any idea for the next videos, other applications that can be done using agents, please feel free to comment it, and I will definitely record the interesting ones. So until the next time, take care. Hi everyone, I'm Mohammed, and by the end of this video, you'll be able to create your own AI agents that can code for you. Imagine assigning tasks like generating and solving a random maze or running 1,000 coin toss experiments to visualize the results, all automatically. We'll start from scratch and build a code developer agent and a code executor agent that collaborate as a team. Then we'll wrap it all up in a Streamlit web application to showcase their teamwork. Let's dive in and make a team of agents work for us. Okay, so we'll do this project in 2 steps. Initially, we will develop the backend side and then the front-end side, just like the previous videos. In the backend side, we'll define 2 agents. One of them is an LLM agent and is a code developer. It gets a task and develops a code for solving that task. And then the other agent, which is not an LLM, is a code executor. It can just execute the input code and spit out the result. And these 2 agents engage in a conversation until the task is accomplished. So, for example, I asked the team of these 2 agents, what is the 17th prime number? And the code developer will write down a piece of code that calculates the 17th prime number and passes that code to the executor agent. And that agent runs the code. Well, if the code is successful, it will just return the result. Otherwise, it will return the error, and the code developer can rewrite the code, can modify it to solve the error. And this goes on and on until we have the answer, and then the code writer, the code developer agent, will return the final answer. So without further ado, let's start. So let me first define the code executor agent, since it is new in our playlist. The other agent, the code developer, is an assistant agent. We've seen that in previous videos, but this is our first time encountering with the code executor agent. So I would say from AutoGen agent chat import agentchat.agents import code executor agent. And the code executor can do one of the following 2 options. It can execute the code in the current environment, but there's a slight chance of disaster, because maybe the code does something disastrous, and then our system will be at risk. But the other option is to pass it to make it use a Docker container. So it will run the code in a Docker container, and it will make sure that there is no harm in our current operating system. Even if something disastrous happens, we're safe. We just lose a Docker container. So I also need to install Docker. If you don't know how to install Docker, you can easily search in Google and install it. And once you have Docker installed, you can create a Docker command line executor object. So you should import it from AutoGen ext.codeexecutors.docker from AutoGen import Docker command line code executor. So we should initially create an instance of Docker command line code executor. And as you see the documentation suggests, the default image is a Python 3 Slim image. So it's a standard image, and most of the time it will do your work. But if you need a more specific Python version, you can also pass it your own image. You can create your own Docker image and pass the name. And also you can name the container, but these are not necessary. These are not mandatory arguments. These are optional. Another argument that is common is the working directory. So you can specify what folder to work on for the Docker. This folder will be mounted on your Docker container, and you'll also see it in your system. So I would say create a temp folder and do your stuff there. And I believe this is enough for the Docker command line executor. And now we need to define the agent, the code executor agent. I would call it code executor, and it will be a code executor agent. So we should pass a name. I would say code executor, just like this. And then we should pass the code executor object, which is our Docker object now. And we're good to go now. Okay, if I want to show you how this works, as you see, we didn't pass any LLM, any large language model. So this is not an LLM agent. This just gets an input, finds the block, the code block for Python or Shell, and executes that block and returns the result. So I can say this is my code. Let's say something like this. Print hello world. Yeah, just this one. And now I want to pass this code to the code executor agent. And by the way, just to practice reading the documentation, we want to see how to feed this code or this prompt to our agent. And of course, it shouldn't be this way. It should be presented as a code block. So it should be like this, Python. And yeah, something like this. So let's practice reading the documentation. Well, at the end, we need to call the onMessage function, but let's see. Let's go to AutoGen documentation, and we have this agent chat, and let's go to the API reference. Okay, we have agent chat agents, and as you can see here, we have the documentation for code executor agent. Its base class is the base chat agent, and if you take a look at base chat agent, it has a method on messages. Yeah, this one. So as you see, it gets a sequence of messages, a list of messages, and also a cancellation token. I will talk momentarily about what is cancellation token, and then it will return the result as a response. So, well, the messages is clear. We need to pass a sequence of messages. Well, right now we have just one message. We have one input. And then it also gets a cancellation token. And the reason for having this argument is that the process for any agent is inherently an IO bound process, input output bound from our side, because we don't do the whole process. We just ask a server such as OpenAI server or an exterior side, and the processing goes on there, and we don't care about the process, and then we get the result. This is how we look at an agent. It's just a black box agent. So maybe while waiting to get the answer, we decide something else. We want to cancel the process. We don't want to we get the response from that point on. So we need to somehow be able to cancel the process, even when the outer side, the exterior side is calculating and finding the response for us. So this is why we have cancellation token. We create a token there, and then whenever we decide to cancel the operation, we can call this cancellation token cancel method. And as you see, cancellation token is in AutoGen core library. So let me import it from AutoGen core, import cancellation token. Okay. So, and of course, our agent will work in async mode. I've talked about async mode and the concept of async briefly in previous videos. And just to repeat myself, we have two practices of coding. We can do it synchronously or async in the async way. So in the synchronous way, here's what happens. While we're executing a line, we wait there until we have the result, and then we proceed to the next line. But in the async mode, in the asynchronous mode, maybe we have several different processes. They are IO bound, they're input output bound. The bottleneck is not the process for us. The bottleneck is just waiting to get the answer from some exterior side. So here's where the async paradigm can help us. Instead of waiting there, we can do other tasks that are not directly dependent on the current task. So this helps us to execute our whole project way faster. And it is the same in the agents world, because we look at agents as black box. Well, some of our agents, or I can say most of our agents, are LLMs that we just use their APIs, and the core computation is done in OpenAI servers or Google servers for Gemini, for example. So while waiting there, we can do other tasks. Maybe we want to run several agents at the same time, and we don't necessarily need to wait for each of them and then go on to the next one. We can feed all of the agents some inputs simultaneously and wait for the answers. So this is why we want to do it in the asynchronous way. So I need to import the async IO as well, and I need to define a coroutine. Again, a coroutine is a function in async mode. I will call it main for now. And instead of calling a function, I should await them. So I say result equals await code executor dot on messages. And for the messages, well, I need to define a text message. A text message object is the kind of message that travels between different agents in AutoGen. From AutoGen agent chat dot messages, import text message. And the text message needs both content and a role, a source, sorry. So here's the content. Content is the code, and role is, let's say, user for now, or it can be anything. And then I need to pass the cancellation token. Cancellation token is a new object of cancellation token class. And in the end, I will print the result. And I need to create an event loop, async io.run main function. This will create the event loop for us. Okay, so let me run dev.py. Python dev.py. Okay, so we have an error. Let's see what is the error. Text message, and this is the role. Content is the code. Okay. Oh, sorry, it shouldn't be source. It shouldn't be role, it should be source. So the text message was not, the argument for the text message was not valid. And okay, we have a new error. Container is not running, must first be started. Okay, we need to start the Docker container before using it. So I can say docker.start, and in the end I need to stop the Docker container. So here I would say docker.stop. Okay, now let's see. Again, Docker is not, the container is not running, must first be started. Okay. Maybe I should start it after. Yeah, I should start it after the code executor agent. and this is not the reason again. Oh, the reason is that I should await docker.start. So, and also for stopping, because I'm working in async mode, I cannot just call it. It's an async method. So let's run it now. Okay, we see the answer. The script ran, then exited with an error, and this is the error. Expected indent. Okay, it's an indentation error because it's running a Python code and it's just one line. So this is actually a tab here. We shouldn't have a tab. So let me remove the tab, and now it should be fine. Yep. You see the content is hello world and the code ran successfully. But we don't need to really do this to call the onMessages method from the code executor, because just like the previous videos, we will form a team in the end and that team will handle all of these operations. So this was just an illustration of how the code executor works. And now we will define the code developer agent. So let me import the assistant agent. So again, as we've talked about it in our previous videos, an assistant agent is an agent that has an underlying LLM, and we can feed it a prompt and it can return the result, the output, based on that prompt. It can also access some tools, but today we will not be working with the tools. We will just use the LLM and define the assistant agent with the name of code developer, and then that agent will be in conversation with the code executor. So here's the code developer agent. It's an assistant agent, and the name will be code developer, and then I need to specify a model client. This is actually the underlying LLM that this assistant agent will use. So let me define the LLM here. For that matter, I need to import the OpenAI client from AutoGen extension .models.OpenAI. Import OpenAI chat completion client. So this will be my model, an OpenAI chat competition client. And I need to specify the model. I will use an O3 mini for today. And I need to pass my API key, which will be inside this API.text. So let me read it. Open API.text.read.strip. Well, that read reads from that file. That strip makes sure there's no extra space in the end, because sometimes when you save a file, there is just one extra line, extra empty line that can cause some errors if you pass it to the OpenAI servers. And again, please don't copy and paste your API key directly here. Try to keep it in a separate file and try not to push that file in a GitHub repo. Or you can also define a system variable for your OpenAI API key, but this is good enough. And now we should pass the model as model client to the code developer. And we need to specify the system message. And this will be my system message. Okay, you are a code developer agent. You will be given a task and you should develop or write code to solve the task. Your code should only be in Python or Shell. at the beginning, you should specify your plan to solve the task. Then you should write the codes to solve the task. And I should also say that you should always write your code in a code block. You should always write your code in a code block with language Python or shell specified. You should write one code block at a time and then pass it to the code executor agent. I haven't introduced the code executor agent, so let me do it here. You'll be given a task and you should write code to solve the task. You are a code developer agent working with a code executor agent. And yeah, you will be given a task and you should write code to solve the task. Okay, it's fine now. You should write one code block at a time and then pass it to the code executor agent. Once the code executor agent executes the code and you have the results, you should explain it and then exactly say terminate. We use this terminate expression to terminate the chat because we don't want the chat to go on and on when it's finished. Okay. Now we have the code developer agent and the code executor agent. The only thing remaining is to define their team. So as you can remember from our previous video, we can have several kinds of teams in AutoGen. The one we'll be using today is the round robin group chat. So from agent chat, AutoGen underline agent chat dot teams import round robin group chat. And what is a round robin group chat? It's a team in which there are some agents, some participants, and they will deterministically behave in the team. So for example, we have the first agent, then we feed the output to the second agent, then to the third agent, and then again first, second, third, first, second, third, or to any number of agents that are present. So in our current team, we have only 2 agents. So initially, the code developer will develop something and will pass it to the code executor, and then it will return the result to the code developer, and then again code executor, and so on and so forth. So let me define the team here. Team is a round robin group chat. We need to specify the participants. So it will be the code developer and the code executor. And we need to define the termination condition to be able to terminate the chat once we have the result, once the code developer says terminate with capital letters. So I need to import the code termination object, the code termination class from AutoGen. I guess it was in AutoGen core dot, let me see, dot models, or dot base maybe, or AutoGen agent chat dot base import, yeah, No, I can't remember. Let's check the documentation. So how can we find it? We should see the team part of the documentation. Let me go back here. We have the agent chat, and we have the teams, then the round robin group chat. It's okay, we need the termination condition, right? And for the termination condition, I can see this is the class I need, text mention termination. Yeah, it is inside AutoGen agent chat.conditions. .conditions import text mention termination. Okay, so what this class does is whenever a particular expression is mentioned, it will terminate the chat. The name is self-explanatory. And what is that text, that expression? It's terminate with capital letters. And do I need to specify anything else? Yeah, the maximum number of turns. So, I want to say at most you need to have the chat going on in 10 turns, not more than that, because I don't want the chat to go forever. Maybe something's wrong and I want to stop it after a while. And now I should call the team. So I would say result equals await. I can call the team in several ways. We've seen it in previous videos. I can say, there is a run method. The bottleneck, the downside of the run method is that we've seen this in the previous video for the agents engaging in a debate. So whenever we use the run method, the problem is that we should wait until the end of the chat. So maybe it goes on for 10 turns. We should wait until the last moment, and then we have all the results all together. But we want to see the progress gradually. We want to see how the agents respond, one after each other, and somehow, not in exactly real time, but somehow in real time. I don't want to wait until the end. So here's what I should do. I should iterate. So I need an async for message in team.runStream. So this is a generator, and just briefly, what is a generator? A generator is a function that whenever it returns or yields something, it stays there, and when we call it again, it continues. So how can this concept help us now? The agents start whenever the first agent yells return or yells some response, we will have it, and then we call it again, and then it passes the message to the second agent, and then it yells the result again, and then we go on and go on. And we can, by doing these iterations, we can gradually see what the agents are doing. Okay, and the run string takes a task, and task can be a string. So what is our task for the team? Well, let me define a variable for task here. I can say, what is the 17th prime number? And I will pass this task as the task argument of runStream method. So this message can be one of the following two types. It can be a text message. That is, as I said earlier, that is the type of the message that the agents communicate between each other. And it can also be a task result object. And when is it a task result object? In the end. When we have all the results, when the chat is complete, it will return a task result object. So I should handle them differently. I should check if message is an instance of task result. And I need to import task result as well. So I would go here and from AutoGen agent chat dot, I guess it was base import task result. Yeah. Even if we didn't know, if we didn't remember which class to import task result from, we could have gone to the documentation and we could check. Let's go to agent chat, and we have the team, we have the round robin group chat, and again, this is a child of the base group chat, and the base group chat has the run method. You can see it here. In the end, it returns a task result, and here's the task result from AutoGen underline agent chat.base class, base library. Okay, so if message is a task result, maybe I can just print out the reason to stop the chat. Was it because the maximum number of terms has reached, or maybe the termination expression has been mentioned? So let's see what it was. I would say stopping reason is message dot stop reason. And else, this is the case that message is a text message object. I would say print message dot source, and then a column, and then message dot content. And after all, say print task completed. Let's see. Let's run this code. You see the user message, what is the 17th prime number? And done. So here's the code developer. Plan, I'll write a Python script that finds the 17th prime number by iterating through natural numbers and checking for primality. Once computed, the result will be printed. And this is the Python code, but it hasn't waited for the code executor. It has, the code developer has thought that this is the right code and it's enough, and then it has terminated the chat. This is not good. So I should change the system message. Okay. Pass it to the code executor agent. Once the code executes the code and you have the result, you should explain it and then exactly say terminate. Let me add some more detail. Never say terminate before the code executor has returned the result, the execution result of your codes. Okay. Of all your codes, and you are sure there was no error while executing. Okay. Maybe this helps. Let's see. Okay, yeah. Now it has asked, please execute this code. And then this is the code executor's output. The 17th prime number is 59. And then the code developer says, the script correctly computed that the 17th prime number is 59. And then it says terminate, and we're good. Let's test it with some other task. I can say, let me comment this one. I can say sum the numbers from 1 to 100 maybe, and print the result. Just this one. a fairly easy task, but I just want to make sure everything's all right. Yeah, you see the code is so easy. Sum of range of 1 to 101 and print it. And the code summed the numbers from 1 to 100 using the built-in sum function with the range function and printed 50/50. Okay, so we have a working pipeline now. We have a code developer agent and a code executor. You know, this was really what most of us developers were doing back in maybe 2023 and the end of 2022 when ChatGPT was initially released. In many times I've seen many guys that pass a prompt. At that time they passed a prompt to ChatGPT, and ChatGPT would then develop a code, and then they would copy and paste it into their interpreters, their IDs, and if the code was executed successfully, then they were happy. Otherwise, they needed to copy and paste the error themselves into ChatGPT again, and they would ask, okay, what's wrong with this error message, and then ChatGPT would address the error. It was a tedious process, and I really hated it. I would try my best to avoid it because maybe I'm old-fashioned in somehow, but I strongly believe that a developer should be strong enough to deal with the errors himself or herself. But of course, in routine tasks, in daily tasks, we can trust LLMs and it's fine. But in critical tasks, you should never trust an LLM. You should supervise it pretty intensely. Okay, so we have a working pipeline now. Let me ask for a more difficult task. So I want to somehow see the law of large numbers in statistics. So toss a coin 1,000 times and print the number or the ratio of heads to all tosses. Toss a fair coin maybe. Let's run it and see the result. Okay, this is the user's message. This is the code. You see it. And yep, ratio of heads is 0.487, close to 0.5. Fair enough. And maybe I can say 1,000,000 times and see what happens. And by the way, whatever code that the developer creates or comes up with is saved in the temp directory, since we've specified temp as the working directory of Docker. Okay. Now I'll write the code in Python. Oh, it hasn't waited for the code executor again. Maybe I can change the system message again to put more emphasis or do some pretty quick prompt engineering. So once the code executor agent executes the code and you have the results and the code was executed successfully, then you should explain it, and then you should explain the code. I want to put emphasize and implicitly state that the code execution should return the result. The code execution result. Okay. You should write one code block at a time and then pass it to the code executor agent. Once the code executor agent executes the code and you have the result and the code was executed successfully, you should explain the code execution result and in the end exactly say terminate. never say terminate before the code executor agent has returned the execution results. Okay, let's see. This is the task, this is the code, and now we have the code executor result. Yeah, pretty close to 0.5. And let me give it a more difficult task this time. Instead of doing this experiment only once, I want to say toss a fair coin respectively from 10 times to, let's say, 1,000 times with steps of 10, and generate a beautiful plot of the ratio of heads in each experiment. Yeah. And in the end, save the plot as plot.png. Okay, so I have this task now. Let's see if it can handle it or not. Okay, you see the code has been developed and now NumPy was not installed. I expect the agent to use pip install to install the NumPy now. Yeah, you see. And also we had the same error for matplotlib. Okay, it didn't install NumPy. Instead it used random library, but then it ran into a newer error for matplotlib not being installed. Then it used shell to pip install matplotlib. And now I believe the code executor should run this shell script code and should install matplotlib. Yeah, it was fine. You see the script ran. This was the message. The script ran but produced no output. It means that it was successful. And then it ran the code again. And this is the code executor. Again, no output. It means that it was successful. And if I go to temp, I can see yeah, this is the plot. Let me show it to you. Yeah. And this is a beautiful illustration of the law of large numbers. You see, as the number of experiments, the number of coin tosses gets increased, we get closer to 0.5. So this is already good enough, I believe. So now we have a perfectly working backend, and it's time to develop the front end, the web application using Streamlit. So let's see. I will do the front end side in a new script. I will call it app.py. So obviously we need to import Streamlit as st. And just as a quick recap, Streamlit is a framework to develop web applications. It facilitates the process. You can develop a pretty beautiful and standard web application pretty fast using Streamlit. So let me specify the title. I would say my developer agent. And I need a text block, a text area to get the task, So let's say task equals sc.text area, and okay, this is the label, task, and we can have a default task. Let's just copy one of these tasks from the dev.py. So for now, let's just copy this one. It's pretty easy. So this will be the default task. Default task. Okay. And I will also have a button here, a run button. Whenever it's clicked, the clicked variable will be true. And for now, I will also have a container, an empty container here to visualize the chat. So I would say chat is a c.container. And if the button is clicked, well, I haven't connected the dev.py to app.py yet, but just for now, let's say chat.empty, and with chat, just write running for now. And to run the Streamlit app, you cannot say Python app.py. You should say Streamlit run app.py. Oh, sorry. App.py. Okay, so you can see the title here, the task here, and when I press run, it says running. So now it's time to connect the backend side to the frontend side. Let me stop the code. And just the same way we did this in our last video, I need to make this dev.py more modular. So instead of having a main in which we do all the things, I like to keep these separated, keep the team configuration separated from running the team. So let's define a new coroutine, async def team config, and the team needs, we don't need any argument here. We will pass the task later. So I will just copy from the beginning of the main to here, and also to the team definition. Okay, I will copy these scripts to the team config, and in the end I only care about the team, so let's return the team. I can also move this Docker start in the next coroutine. Instead of having main, I would rename it to run, and it gets a team and a task, and it runs the task. And you know, since I need to work with the Docker, I need to start Docker inside this run because this is more logical. I don't need to start the Docker command line from team config. It's better to do it whenever I have a task and I need to run the team. So the team config returns both the team and the Docker code executor object. And here I will pass team, Docker, and task. So doing this, let's also move these tasks outside the run. I can define another coroutine here, a main coroutine. I will have the task here, and then I would say team and Docker will be defined from calling team config. And after I have the team config, I can run the team config, the team, Docker, and task. But you know, this will work right now, but this is not what I was hoping for. Inside my app.py, I want to do this in async mode as well. I want to gradually visualize the chats. I don't want to do them, I don't want to visualize them once I have all of them, all of the chat. So here's how I would do it. I will define an async generator here. I will change the run. I will modify it to be an async generator. And this way I can iterate over this generator inside my Streamlit app. And I will visualize the chats once I have every dialogue. So, I start Docker here, and then for message in run stream. Okay, I will define this as message, MSG, and instead of just printing it, I will yield the message, the MSG. Same here, I will define this string as MSG, and I will yield it. And in the end, I will stop Docker. And yeah, instead of awaiting like this, I can now say for message in, and it should be async for because I'm running it inside a coroutine. Async for message in run team Docker and task. Well, I need to do absolutely nothing because I'm printing it inside the run coroutine. So let me run dev.py. It should run successfully. Okay. Yeah, it is running, we can see. It developed an initial piece of code. It had library issues. NumPy was not installed in my Docker container. And then it installed, again, it used random, and then it installed matplotlib, and then we have the result. Oh, it's still running. Okay. But I don't need to run that really. I know it works. And the only thing I care for now is that dev.py is a standalone code. It can run, independent of app.py. And now I can use these two coroutines, the run and the team config, inside app.py. Okay, so let's say from dev.py, from dev import team config and and run. And now I can, inside this if statement, whenever the button is clicked, I would say chat.empty, clear the chat container, and then I would say inside the chat with chat. Okay, I need to define a coroutine now. So, and by the way, let's do this before the chat context manager, the with chat statement. So I would say async def run task, and it gets task. And then I would say team and Docker will be specified from team config, and then async for message in run team Docker and task. And okay, now I would say, inside this coroutine, I would say with chat, and for each message, if the message is from the code developer, I want to display it differently with a separate avatar, and if the message is from the code executor, I want to display it with a different avatar. So let's say with Streamlit sc.chat message. It's a component to visualize the chat. It gets a name. I would say this is for AI, and I can pass an avatar, or I can not pass anything, because AI is a defined expression in Streamlit chat message. It has its own avatar. So with sc.chat message from AI, sc.markdown that message. This makes sure that the message is formatted as a markdown. And then, and I should do this if I'm sure that the message is from the code executor, the code developer. So I would say if message dot starts with code developer, in that case, display that message as AI message. And if the message is, if the message starts with code executor, then display it as a user, and yeah, st.markdown. I guess we're fine now. I just need to create an event loop. So import async IO. And outside this coroutine, I can say async io.run, run task with my task. And let's see what we have so far. Streamlit run app.py. Okay, let's run. Okay, this is the code developer. This is the plan. This is the code. This is the code executor's result. And yep, this is the code developer result. The code found that the 17 prime number is 59. This is the explanation, and we're done. Terminate. Okay, so I have a pretty working UI now, a pretty working web application now. Just out of hobby, I would like to add this option to visualize an image inside this chat, because right now if it produces an image, I cannot see it inside the chat dialog. For example, if I say plot the first 20 numbers, 20 prime numbers as a beautiful chart and save it as prime.png, it will work, it will save it, but it will not visualize it inside the chat dialog. So let's see. Yep, this is the code, and then it has used matplotlib. It wasn't installed. It is trying to install it now. And okay, this is the answer from code executor. It has successfully installed matplotlib. We have the code now. I guess we have an error again. Yeah, exited with an error. It was for Seaburn Dark Grid. The file was not found. So then the code developer revised the code, and now the plot saved as prime.png successfully. So we have the plot now, but it is not displayed here. Of course, I can take a look at it at my VS Code, and you see it is correct. You know, we have some plot, but I want to display that image inside my chat dialog. So In order to do that, I need to somehow get aware whenever an image is generated. So maybe I can add something I can modify the system message of the code developer. So before saying terminate, I wanted to declare that it has generated an image in a structured way. So once the code executor agent executes the code and you have the results and the code was executed successfully, you should explain the code execution result. Okay. You should then, if an image has been generated, you should then exactly say something like this: generated and file name. Like, let me give it an example. This is somehow a one-shot learning. Generated plot.png, something like this. And in the end, exactly say terminate. Okay. Now I expect it to say something like this. It should include this expression, and then I can visualize it. I can check the messages. Once I have that pattern, I can fetch the file name, the image name, and display it. So I can say, I have the message here, and I will say if generated in message, I need to fetch the file name. The file name would be message.split from generated. So, and the first, whatever comes before generated will be index 0. Whatever comes after generated column will be index 1. And I need to strip. No, I don't need to strip it. I need to split it again for spaces, because maybe there is some space after that. I can even do it this way. The default value is to separate by spaces. And then I need to get the first element, because after this part is executed, I have whatever comes after generated colon. Well, the immediate expression will be the file name. So I will split it from space and get the first element, which is the immediate expression after generated. And then I can display it using scimage. And of course, this is located inside the temp folder. My agents aren't aware of that, so I need to take care of. I need to make sure the path is correct. So I should say scimage is os.path. Join temp with file name. Or if I want to do it more professionally, I should first check if that file exists. So I can say file path will be os.path.join temp and file name. Then if the path exists, do it this way. If the path exists, display it. Otherwise, declare that this file was not found. And just to make my application look more professional, I can use a spinner object. Whenever the agents start working, I can say with st.spinner running. You will see there will be a rounding circle. And once it's done, that spinner will disappear. Okay, so let me run the Streamlit app again. And let me copy the coins task. Where was it? It's here. Okay, let me copy this task. And I don't need to keep it in several lines now. Okay, this is good. Run. You see, this was the spinner object. It's at the bottom until all of the chats are done. I'm seeing a particular behavior now. Matplotlib was not installed, it got an error for that. But now instead of doing it with the usual shell script way of doing pip install, it is adopting a different approach. I don't like this kind of approach. This code isn't that clean. So I can specify in the system message of code developer that whenever the library isn't installed, you shouldn't do it this way. You should use shell script. But anyway, you see, we have the image now. So right now we have our chat, and in the end, since we had an image, we can see it. So right now we have a team of agents, a developer, a code developer agent, and a code executor agent. And we can give them, many of our daily tasks, daily development tasks, and they can solve the task for us. So one current limitation of our approach is that, we have a maximum turn variable. We have this max turn. 10 is relatively small. Maybe I can set it to 40, because if I have a more sophisticated task, it will definitely take more than 10 turns to accomplish it. And I also would like to specify that if a library wasn't installed, use shell script to pip install it. So let me also specify that. And if the code executor agent returned an error due to library not being installed, you should use shell script code block to pip install it. Okay, this will make sure it will never again install the library inside the Python code. And now I would like to give them a more difficult task. It is interesting to me. Let's see if it can handle it or not. So I would say generate a random maze. Yeah, let's generate a random maze and then solve it and then visualize it with an animation and use a path finding algorithm to solve it and display the solution step by step using animation and save it as maze.gif. Okay. Let's see if it can handle it. And by the way, while we're waiting, you can always change the appearance of your system. Right now my theme is dark, but maybe you would prefer light. Okay, this is the code developer plan. and this is the code, and this is the solution function, and we have the create animation. NumPy, Matplotlib, and Image.io are not installed, and you see it is now using shell to install all of them. Again, we have this code, we have an error, again we have an error, it has revised the code, and it was solved and saved. But the GIF isn't that clear. Let me check it. No, I don't like the current version and it's not working. So one limitation of our current approach, you can see it already, is that we haven't specified a role for a human to, intervene and send a feedback. We can always start from scratch. We can say, we can run this again and we can maybe modify the prompt and try to improve it. Generate a random maze and use a pathfinding algorithm to solve it and display the solution step by step using an animation. It should have the whole maze and a red dot that starts from top left to get to the right bottom, and the trajectory should be displayed gradually. Save the animation as maze.gif. Okay, let's run it again and see if it works. Again, we have a problem with NumPy not being installed. Now we have a problem with Matplotlib not being installed. It is now installing Matplotlib and Pillow. We have the code again, a revised code. Again, we have an error. It's just like a human developer. We usually do the coding and then we have some errors along the way and then we try to address the errors. Okay. Yeah, you can see. This is so beautiful. I really like this version. And let's see if the dot can get to the right bottom. Yeah, this is good. Okay, so we've seen how to start from scratch and develop a team of a code developer and a code executor agents, and how they can help us accomplish a programming task. So I hope you enjoyed this video. I strongly encourage you to do the same project, try to do it yourself from scratch without consulting this video or the documentation. Of course, watch this video, you're more than welcome to watch it carefully, but then it should be all you and the internet. So if you want to be a strong developer, you should start from scratch. Whenever you face an error, you should try to address it by reading the documentation and searching, reading documentation, asking ChatGPT, for example. And the only thing that matters is that in the end, you should be able to do your project. Okay, if you're thinking of a better application of agentic AI, a better and more interesting task in which agents can help us, please feel free to comment it for me, and I will definitely record some tutorials on the interesting recommendations. I hope you enjoyed watching this video. Until the next time, take care. What if your dataset could talk to you? Imagine asking a question from your dataset and getting an instant answer. First, we upload our dataset, then prompt, create a visualization of the data. Here's our AI agents at work. Developer crafts the code and executor runs it immediately. And there it is, your data brought to life with a dynamic chart. Now I ask, what insights can you spot? Developer and executor dive back into chat. And in seconds, they highlight key patterns and surprising trends. No manual coding required. I'm Mohammed and I'm gonna teach you how to develop this agentic app from scratch. Let's get started. Okay, so we'll be developing this project in two parts. In the first part, we'll develop the backend side, the agentic part. And in the second part, we'll develop the web application with Streamlit. And I've downloaded a dataset beforehand. It's called Netflix Movies and TV Shows. Let me show you the dataset. It's a CSV file containing information about many movies and TV shows of Netflix. You see for each movie or TV show we have title, we have director, we have cast, and rating, duration, and so on and so forth. If you want to download this dataset, you can go to Kaggle and you can just easily search Netflix dataset CSV, and yeah, there we are. This is a dataset, and you can also see some information about different features in the dataset. And if you want to download it, just you need to sign in and you can easily download the CSV file. Okay, so let's develop the backend side as a separate Python file, and then we'll develop the front-end side in another file. So let's call this data.py, and we'll be working with AutoGen like previous videos. We'll be working with the most recent version, AutoGen 0.5. It's a stable version, and we need two agents in this project. The first agent will be an assistant agent. It is an LLM, and it will provide Python code to answer the question. And we will have a code executor agent. It will execute the code developed by the code developer agent in a Docker container. So without further ado, let's start coding. First thing first, let's import from AutoGen Oh, I need to change my environment. Okay, AutoGen. From AutoGen agent chat dot agents import assistant agent, and we need to pass a model, an LLM, to this assistant agent. So let me import the model as well. From AutoGen x dot OpenAI or dot models dot OpenAI import OpenAI chat completion client. And by the way, we'll be working with O3 Mini, although O4 Mini was released yesterday, but I couldn't access it through API yet. So let's just work with O3 Mini, just like previous videos. And again, we'll be developing in asynchronous mode. So let's import async.io, and I will define a coroutine, a function in async.io, async def. Let's call it main for now. And here's my model. Model is OpenAI chat completion client. And I need to pass what model do I wish to use, O3 Mini. And I also need to pass my API key. So I forgot to bring my API key here, so now I will copy it. Okay. Just as I've explained in previous videos, please never share your API key with anyone. Share it with GitHub, never push it to your repo. Make sure it's safe. You can either introduce a system variable, or you can keep it in a separate file and make sure it is not public. So open api.text.read.strip. .read just goes and read the whole file, and .strip make sure there's no extra space in the end. So we have the model right now, and here's the developer. It's an assistant agent. We should pass a name. I will call it developer. And we should also pass a client, model client. It will be model. And I need to specify the system message. And as you see, sometimes GitHub Copilot suggests the wrong syntax, so please never trust it blindly. It is so common, especially in these libraries such as AutoGen. They're pretty new and it isn't trained well on these libraries. Okay, so you are a developer agent, code developer agent. You will be given a CSV file and a question about it. You can develop Python code to answer the question. I should specify that it needs to come up with code in code blocks, because my code executor only accepts code blocks. So you should always write the code in a code block with language which is Python specified. Okay, and let me also specify that the agent should first come up with a plan and then develop the necessary code. Let me specify this. You can develop Python code to answer the question. You should always begin with your plan to answer the question. Then you should write the code to answer the question, and You should always write the code in a code block with language specified. If you need several code blocks, make sure to write down one at a time. And I should also say that you'll be working with a code executor agent. You will be working with a code executor agent. Once you have a code block, you must wait for the code executor agent to execute the code. If the code is executed successfully, you can continue. And once you have the code execution results, you should provide the final answer. Okay, it's good for now. And yeah, so this is the code developer agent. I should also define the code executor agent, and let me define it. Code executor agent, I should import it first. AutoGen has a Docker class, has a class to work with Docker, so I should also import that as well from AutoGen x dot code executors dot docker import docker command line code executor. Okay, so I will define a Docker object. It will be a Docker command line code executor. I can specify the image. Let's go with Python 3 Slim, the default image for now, but we can also specify other images as well. I can also pass container name or let it decide, or I can pass a working directory. So the name is, I don't need names for this, sorry. Yeah, working directory will be a temp folder, and we're good for now. And here's the executor agent. It will be a code executor agent object. The name is code executor, fair enough, and it needs the code executor object. I will pass Docker. Okay, so now I have two agents, the developer and the executor, and I should make a team out of these two agents. As you can remember from previous videos, we have three types of teams in AutoGen. Let me show you. So AutoGen documentation. Today we'll be working with round robin group chat, AutoGen agent chat, and here's the teams. So we'll be working with round robin group chat. In round robin, as you can see the description, it's a team that runs a group chat with participants taking turns in a round robin fashion. It means that the team behaves deterministically, so we know beforehand which agent will respond when. So for example, if I pass the code developer and the code executor, it will first prompt the code developer and then the code executor and then the code developer and then the code executor. So they'll just take turns and respond. So let me import round robin group chat from AutoGen agent chat.teams, import round robin group chat. Okay, let me define the team. I will call it team. It's a round robin group chat. I need to pass the participants. It's developer and then the executor. And I can also specify a termination condition. I forgot to mention it in the system message for the code developer. So here's what I want. Whenever the answer is clear and the code developer has the answer, it should say terminate with capital letters in the end so that I will terminate the chat. So let me import. We have a class for this purpose. AutoGen agent chat.conditions import text mention termination. So I can specify whenever a specific text is mentioned, it will terminate the chat. Okay. Let me specify the termination condition. I can pass a text mention termination object. And what is the text? It's terminate. Okay. And I can also specify the max turns. How many turns in the worst case do I wish the chat to go on? And by each turn, we mean one time each agent should talk. Okay, let's say 20 turns for now. And okay, I should also specify the termination in code developer's system message. So once you have the code execution results, you should provide the final answer. And after that, you should exactly say terminate. Okay. Terminate to terminate the conversation. Okay. Now I can test if everything's okay. So as you can remember from previous videos, I can use the run method or the run stream method. I would suggest using the run stream method because if you use this method, you will have the response of each agent once it is ready. You shouldn't necessarily wait until the end of the chat to have all the messages. So I can have an async for loop. I can say async for message in team.run stream, and I can specify the question now. So let's call it task. For example, what are the columns of the dataset? And let's say my dataset is, I should also introduce the dataset. My dataset is data.csv. What are the columns of the dataset? Okay. I will pass this question as task to the team. And now this message could be either a text message, which is the class that represents the messages between agents in AutoGen, or it can be a run result, I guess. Maybe I'm wrong, but I guess it's a run result. So we'll see what it is. And I need to handle these two cases separately. So I should say, okay, if message is a text message, so if is instance message and text message, and I should also import text message from AutoGen agent chat.messages import text message. And to see what will be the returning type of run stream, let me read the documentation. Yeah, it's a task result, sorry. So it could be either a text message or a task result. So if it's a text message, just print message that we have a role for, we have a source for the message, for the sender of the message, a column, and message.content. And else if message is an instance of task result, and I should also import task result as well from AutoGen agent chat dot teams import. Let's see if we have task result here. No, I cannot remember where to import it, so let's check the documentation. And by the way, this is a very important skill to be able to extract the answers to your questions from documentation or GitHub. So practice this skill is really important. I have round robin group chat, and I want to see the documentation for the run result method. Since a round robin group chat has a base class, the base group chat, I can go to base group chats documentation, and here's the run, and here's the run stream. Yeah. And here's the task result. And you can see task result is in AutoGen agent chat.base. So AutoGen agent chat.base import task result. Okay. So whenever it's a task result object, I just want to see what was the reason for the chat to stop. Maybe the max turn has reached, or maybe the terminate expression has been mentioned. So print stop reason and message.stop reason. Now I can run my code and see if everything works. So if name equals main, async.io.run, the main coroutine. So this line just creates an event loop, and if you don't know what is an event loop, don't worry about it. In async.io, we need an event loop so that it can run different coroutines. And by coroutine, I mean just think of a coroutine as a normal function, but instead of waiting for that function to execute and doing nothing else, we can execute several coroutines at the same time. It's especially beneficial when our application is IO bound, when we're waiting for some outsider to provide the result for us, and that is the case for the agents. That's usually the case. So let me run the code. Python data.py. Oh, I forgot to start the Docker object. We should start it, and in the end we should stop it. So before the team starts working, I need to say await. Await keyword is used to call a coroutine. So await docker.start, and once the chat is done, I can say await docker.stop. Okay, let's run the code again. You see pandas was not installed, and it installed pandas, I guess. Let's see what happened. This is our message, the user message, and then this is the developer's response. The plan is to load the CSV file, extract the column, and print the list of columns. And this was the code provided by the code developer agent. And the code executor tried to run the code, but it failed because pandas was not installed. So it's a good idea to also mention pandas in the system message, because sometimes it might try to use other tools, but I wanted to use pandas most of the time if it's suitable. So since pandas is not available, I use the built-in CSV module. So it now tries to work with the CSV module, and it couldn't find data.csv. And that's because my data is here, but the working directory of Docker is here. And you can see the codes that it developed goes into these temporary files. Okay. So for now, let me just copy data.csv into the temp directory. Copy data.csv into temp. Okay. And now I can also specify that you should use pandas most of the time. You are a code developer agent. You'll be given a CSV file and a question about it. You can develop Python code to answer the question. You should always begin with your plan, and you should always write the code in a code block. If you need several code blocks, do this and this. You will be working with a code executor. You must wait. So you can continue. Okay. Use pandas to answer the question if possible. If a library is not installed, use pip to install it. And use pip in a shell code block with shell specified to install it. I'm saying this because in a previous video we saw that when we didn't specify this sentence and this instruction, it tried to install the library inside the Python code, which is really which makes the code really ugly. So that's why I'm explicitly asking it to use pip install in shell code block instead of trying to come up with a creative or with an ostensibly creative way. Okay, so let me run the code again. Yeah, you see pandas was not installed, and now it tries to pip install pandas. And don't forget our question, it was this one. What are the columns of the dataset? Okay, this is the code and these are the columns. And this is the developer's final answer. And after saying the final answer, we have the terminate expression, and the stop reason is that text terminate was mentioned. Okay, so we're good now, but let's postpone the improvement after we have a minimal UI. So now we have a working team. We can pass a question about our data and they will provide the answer for us, a code developer and a code executor. So I can say we're in a safe spot now for our backend, for our agentic part. Let's develop the web application with Streamlit. So let's create app.py and let's import Streamlit as st. So here's my plan. I want to file upload dialog to be able to upload my dataset, and then the user opens the dataset, and then I would like to have a text input at the bottom, just like ChatGPT or other chatbots, so that the user can write the prompt, and once we have the prompt, then the agent start working. Okay, let's start. I can specify the title, st.title, talk with your dataset, and Streamlit has a bunch of elements to facilitate chat visualization. So one of these elements is chat message. We've seen this one in previous videos. The other one is a chat input. So it will be the text input at the bottom so that we can write our prompt in it. I would say prompt equals st.chatInput. Okay, I can specify the placeholder. Let's say ask a question about your dataset, something like this, and that's enough. And I should also specify a container object to visualize the chat in. So container is an st.container, or let's call it chat container. And just to illustrate how this works, let me say if prompt, if we have any prompt with chat container st.write. Fair enough, you asked prompt. Okay, let me run this web application. Of course, it's not connected to the backend yet, but let's see how this logic works. Python, oh, and I cannot say Python app.py, so I should say Streamlit run app.py. Okay, talk with your dataset, ask a question about your dataset. I would say anything, and I have it here. Okay, so let's connect the data.py to app.py now. Let's connect the backend to the frontend. As you've seen in previous videos, I would like to do it in a more modular way. So I will split this main coroutine into two coroutines, a coroutine for team configuration and a coroutine to orchestrate the team. So let's say async def team config, and it doesn't need anything. I will copy from the beginning to the definition of the team. So this will be the team definition, and in the end I will return the Docker object and the team object. So return team and Docker, and instead of main I may call it orchestrate. It gets the team object and the Docker object and the task. And here's how it works. I will start Docker. Instead of hard coding task here, I will put it outside this coroutine. So await docker.start, and then for each message in team.runStream, just print the message. Okay. And now I will define a main coroutine. Here's my task. I would say team and Docker equals await team config. After you have team and Docker, I need to orchestrate. This will work now. Let's see if it works or not. No, I don't want to execute. I don't want to run the Streamlit app now. Let's just run data.py because I want it to be standalone. I want it to be able to run successfully independent of the front end. And you can see now the agents are working. Pandas was not installed initially, so it is trying to install pandas, and it will eventually work and provide the correct answer. Okay, So here's the final answer, and here's the terminate expression. Let me clear the terminal. So here we are, but again, I don't like this version. I want the orchestrate to be an async generator so that I can access each message once I have it. So instead of just printing the message, I will call it message, and I will yield message. And for stop reason, do I need that? Yeah, let's say I also want to visualize the stop reason in my web application. So the same way, I will define the message and I will yield the message. And if I want to orchestrate the agents with this new configuration, with this new architecture, I would say I need to iterate over this generator. So async for message in orchestrate team docker and task. And do I need to do anything? No, because I have print inside this orchestrate coroutine, or it's not really a coroutine inside this orchestrate async generator. So I can just pass and the code should work again. Let's see. You see pandas was not installed. It is trying to install pandas again. You see, here's the final answer, and here's the terminate. So now I can use these two coroutines, I mean the team config coroutine and the orchestrate async generator inside my web application. Let's import them. From data, import team config and orchestrate. Okay, so once I have a prompt, I would like to create the team and Docker object and then orchestrate the agents. I will define a coroutine here, async def, let's say query or whatever name, and I need to import async IO as well. Import async IO, and inside the query I will create the Docker and team objects, await team config, and then I will like to iterate, I should iterate over the orchestrate generator. So async for message in orchestrate with team, Docker and prompt, and then okay, now I need to work with st.chat message. It's an element to visualize each chat message. So first of all, I should see where this message is coming from. Is it from the code developer or from the code executor? And once I know that, I can change the avatar and the name of that agent, in my visualization. So let's say if message dot starts with developer, this means that this message is coming from the developer. Then I would say with st.chat message, and what is the name? I would say, okay, the name is developer, and I can also specify an avatar for that. But let's say the name is AI because it's a predefined string predefined value for Streamlit chat message, it will have a beautiful icon for an AI agent. So I would say just it's from an AI, and I will render the message with Markdown, and I can say elif message that starts with code executor, in that case chat message, but let's say this is an executor, the name is executor, and I can specify the avatar, and for avatar it was a good suggestion. Yeah, let's go with this one. And I will render the message as a markdown. Okay. So now that I have this chat visualization, I can create an event loop with async.io.run and run this query coroutine. Okay, and now I can forget about this one. So let's say Streamlit run app.py, talk with your dataset, and here's my question. My data is data.csv, list the columns. Okay, you can see here's the developer, here's the plan, this is the code, and now it's trying to pip install pandas since it's not installed. And pandas is installed now. Here's the code again, here's the result, and here's the final answer. Okay, so it's really working now, but one thing that I really don't like in the current version is that I always need to specify what is my file and where is it located here. I don't want to do that. So let's add a file input object, so a file uploader, so that we can upload our dataset each time instead of talking about it. That would be way easier. Okay, so I would say file equals sc dot. We have this file uploader, and the label would be upload your CSV file. I can also specify what type, what extension should it accept, CSV files. And just let me show you how it looks. Okay, now we have these elements here. We can drag and drop our file here, or we can browse our file, and we'll upload our CSV dataset with this element. And I'm doing this so that we wouldn't need to talk about our data. I mean, say, okay, my data is whatever the CSV. So I don't want to do that in every prompt. So I need to write some code to handle this file uploading process. So here's the file. It will be none if there's no file, but if we have a file uploaded, now I should save it. Here's what I would like to do. I like to save the file in this temp directory, and then I will provide this information in the system message of the code developer agent that the dataset is in temp data.csv. So this way, any dataset with any name will be saved as data.csv, so that the agent always knows where to look for it. So let's say with open. Okay, it should be in temp and data.csv. Let's make it OS agnostic. So import OS, and it will be in os.path.join temp and data.csv. Yeah, I want to write bytes and f.write file.getBuffer. This way, any file I upload, any CSV file, will be saved as temp as data.csv in the temp folder. And then, yeah, then display that file uploaded successfully. Okay, let's see. Let me remove this data.csv from here. And let me run the code. Streamlit run app.py. And okay, here's the dataset. File uploaded successfully. You can see. And if I go to temp, you can see here's the data.csv. Okay. And I should also change the system message of the developer agent. You are a code developer agent. You will be given a CSV file in named data.csv. Okay. Data.csv in your working directory. Okay, let's see if everything works. Let me run the app. And here's my dataset. And here's my question, just the same. List the column names. Here's the developer's plan, and you can see it knows that the data is data.csv. And it's waiting for the code executor's response. Sometimes it can take a while. Oh no. The problem is that we have terminate here. In its plan, it has also talked about terminate, so that's why the chat has been stopped. I need to provide a mechanism so that I can get aware somehow when the chat is terminated, and I can also prevent this happening. So, okay, first of all, I need to also display the stopping reason of the chat inside my web application. Although I've done it in the orchestrate function, I'm also yielding the stop reason message, as you can see here. But in my chat visualization, I have just two conditions for the developer and code executor agents. So let's also say else if message starts with the stop reason. In that case, do I need to? Yeah, let's go on. Let's see the chat message. It can be from user and sc.markdown message. I'd also like to have a spinner object here so that whenever the agents are trying to come up with the answer, I want to somehow get notified. So let's say with st.spinner generating response. Yeah. And there you go. So one current problem of our implementation is that, let me show you. Let's run it again. Let's import the dataset. And now let's ask a new question. How many rows does it have? You see, here's the spinner object. At least we know that something's happening. The agents are working. Pandas is installed. You see, we're still working. Okay, so it figured out that we have 8807 number of rows. And here's the stop reason. Text terminate mentioned. Fair enough. But we have a problem right now. Whatever change that happens in this web page, I will lose all of my messages. So for example, let me just get rid of this data.csv. Now all of my messages are gone. So this is because of the logic of Streamlit. This is how Streamlit works. For every change, every event in the web application, it runs this code from top to bottom. It runs this whole code. So in this, when I have an event like, removing a file from this element, or even clicking on any button, if we had any button here, in that case, it runs this code again, and we don't have any new prompt. So this will be none, and we don't go inside this if statement. And that's why we lose all our messages. So I need to somehow retain my memory. I need to somehow remember what messages I had. And this is where Streamlit session states can help me. So I can say, okay, for the first time we're running this code. In that case, we haven't specified messages. We haven't any list to keep track of messages. So in the first time, I want to create a list inside a Streamlit session states. And from the next time on, I don't need to create a new list. I just need to use that list. So I would say if messages not in sc.session state, then create an empty list and call it messages. Okay, so once I have a new chat, once I have a new message, I will append it to my list. So let's say instead of doing it this way, I would say sc.session state.messages.append the message. And I will do it irrespective of who the message is coming from. So I can do this stuff somewhere else. I will create a new function. Let's name it show message. So let's say maybe here's a better place. Def show message, and I have a message, and here I will visualize the message, and I need to also pass the chat container. So show message gets a container and a message, and first of all, inside that container it will say with container display this message. Okay, so I have this coroutine now. Here I would define team and Docker. And now inside the spinner object, I iterate over my orchestrate async generator. Once I have a message, I will append it to the message, and then I will show that message. Okay. And before coming into this if statement, I want to show all my previous messages. So let's say I want to continue the chat once I have the answer. I want to have another question. I don't want to lose my previous chat. So before this one, I would say for message in sc.sessionState.messages, show that message. So if I run this code again, you would see that even if some event happens in the web application, I will not lose my previous messages. So let's ask the same question. How many rows do we have? And this is a pain. Every time pandas is not installed and it tries to install pandas. So maybe I can pass an image that already has pandas installed. So this saves me some time and also some, cost. So we'll do that next. And yeah, the chat is done. You can see. Here's the developer's plan. And in the end, it says, okay, we have 8,807 rows. And now and you saw I removed the CSV and nothing happened. I can, import it again. I still have the messages, you see. And let me do this one. Let me find another Docker image that has pandas installed. Docker image for pandas. Let's search it. Okay, we have this Docker image. You can find it in Docker Hub, and you can just do it this way, I guess. Let's make sure. What is the latest version? Okay. I don't want Jupyter version. Okay, I want this one. So now I can pass it as an argument to Docker. The image should be this one. And let's see if everything's all right. This is my data, and how many rows? Okay, you can see pandas is already installed. It didn't bother to install it again. So now we can have our answer way faster. But we have one more problem. I don't know if you could guess the problem. If you could guess the problem now, congratulations. You have a very good understanding of how the logic of our application works. But if not, don't be disappointed. It's fine. You don't even know what I'm talking about. So what if I want to ask another question? Let's say list the columns, and let's see what happens. List the columns. I have generating response. And now I have the response. But here's the problem. Let me say render them as a markdown list. Let's see what we have. Okay, this is clearly the wrong answer. You can see. Or let me say, what was my first question? Okay. Since the conversation only contains the current question, it appears that this is the only question. Okay, you can see it now. It doesn't have memory. Although we're visualizing all the chats, you can see here's the beginning, and then we have tons of items, but the agents do not have memory. They cannot remember what we asked them the first time and other times. So what can we do about this, and what is causing this problem? Let's take a look at the code. The problem is that whenever I have a prompt, I would create an event loop, and inside that coroutine that is being executed by the event loop, I will create a new team and a new Docker object, and then I will orchestrate the agents. So as soon as I have this line executed, my team of agents has no memory from previous chats. So I need to somehow mitigate this problem. There are two ways that I know of to how to solve this problem. One way is that we can define team and Docker outside this if statement, so that we define team and Docker only once. But then we have another problem. Team and Docker are connected to just one event loop, and after the first question, this creates another event loop, and then from that point on, they don't have access to the new event loop, and this is another problem we should overcome. Of course, we can overcome this problem as well. We can create one event loop at the beginning and keep track of that event loop, and then here we should just say, okay, inside that event loop, run until complete this query coroutine. So this is one way to overcome this problem, but let's do it in a more agentic way. The round-robin group chat or the teams in AutoGen have some state. We can save them and we can load them. So if we can save the state of a team once the chat is done, and then we can load it the next time we create a new team, so this problem will be solved. So let's say I wanna save the team's state. So at this instant, the chat is over, and I can save the team's state. So let's say st.session state team state will be await team.save state. Yeah. And before starting to orchestrate the agents, right at this point, I can check and say, okay, if I have team state in my session state, it means I had some previous chats, then load that state. Yeah, await team.load state that team state. This way my agents have access to their previous chats. So you can see once I have the new team, it will load the state of the previous team or previous chats, and then it knows what I'm talking when I ask about an earlier conversation. Okay. So let me run this and let's hope we don't have any bug. Let's browse the file. And how many columns do we have? For example, okay, I have my answer. And now I can say, let's ask another question. Describe the second column, whatever it is. Okay, it is labeled type and it is one of movie or TV show. Fair enough. So now I can ask, what was my first question? And it should note how to answer that. Oh, and it wrote a code to answer it. It's funny. Your first question was, how many columns do we have? You see, now the agents have access to some sort of memory. And the only thing I would like to do is that I would like to also be able to generate plots of the dataset and visualize them here. That's an interesting option. So I just need to specify this in the system message, and just the way we did in the previous video, the video for a team of agents developing code, I can visualize it in Streamlit the same way. So let's go to data.py and let me add some instructions here. If the user asks you to provide a plot, you should use matplotlib to plot it, and you should save it as a PNG file, and you should exactly say generated file name like generated plot.png, for example. Let's go to the next line. In a new line. And you should save it as a PNG file, and you should exactly say generated in a new line after the code executor has executed the code successfully. Has executed the code and generated the plot successfully. Or let's say after you are sure that, because sometimes it, as we saw it earlier, sometimes it just prints generated file name before passing it to the code executor, and this is not what I want. Okay, so I have this in my instructions, and now I can look for this pattern in my messages, and if I have that pattern, I can visualize it with sc.image. In the last video, I mean the video for the team of agents developing code, I used a simple string method to extract the file name, the name of the plot, but here I would like to use a more professional way using regex or re in Python. So let's import regex, and if you don't know about regex, don't worry about it, it's just a minor thing. It helps us to look for specific patterns in a string, and it facilitates the way we search, and it's a strong way of looking for specific patterns in a string. I strongly encourage you to go on and read about it. So let me introduce a new function, get file name. Yeah, fair suggestion. And I would say match equals re.search. It's right, the pattern is generated, and then a column, and I need parentheses to find out the exact file name. And what can be inside these parentheses? I can say anything other than spaces, and it can be a bunch of them, and in the end it should be a .png. Okay, I guess this works. And if match, if it found anything, return match.group of 1, else return none. Okay, so, and match.group1 just extracts whatever is inside the parentheses, so it will be basically the file name. So once I want to show a message, I should check, and if I have the file name inside that message, a PNG file name in that pattern, I would like to visualize it. So inside the show message function here, I would say file name equals get file name of this message, and if file name, if I have something, or let's do it in a more Pythonic way, if file name, which is this one, then st.image, and it should be inside the temp. Of course, the agent doesn't know about the temp folder, so I should specify it here, temp and file name. And I can also use a caption for it. The caption will be the file name. Okay, let's see if it works. In the first question, I would ask, show me the columns, the column names, let's say. I don't want it to print out the whole data set. Okay, these are the column names. Now I would like to have a histogram of duration or release year. Yeah. So generate a plot of histogram of the release year. Let's see if it works. Okay. It didn't have matplotlib installed, so it installed it. plot saved as release, and yeah, we have the histogram now. And since it's a Streamlit image component, we can also, make it full screen and then go back. So now we have an application in which we can upload our CSV dataset, and we can chat with our dataset. We can ask questions about it. Let me run another example. Let's say, give me some insights about the dataset. You see, it is trying to run some code to get an idea about the dataset. And yeah, the dataset contains this many entries and 12 columns. It represents two main types, this amount of movies and this amount of TV shows. Among directors, these guys are the top 5 most frequent. These are interesting facts about the dataset. And you can also ask it to, for example, how many vsync values are there? So how many missing values are there? And it can answer you quite fast. You see, the code executor executed the code, and for each column you can see how many missing values you have. And you can ask more interesting questions. If you have a funny example, a funny use case for this application, a funny prompt, please write down in the comments so that we can see it and we can get aware of that. So that's it for today. We've developed an agentic application from scratch in which 2 agents can work together as a team, and they can answer the questions about our dataset. We've also developed a minimal Streamlit application, Streamlit web application for that. And you can see the agents have memory. They can plot for you. They can answer your questions. Personally, I find it so exciting, and I really enjoy developing these kinds of projects. If you have any other interesting project in your mind, please comment it, and I'll make sure to record a tutorial for that as well in the future. That's it from me. Thank you so much, and take care. Hey everyone, ever wished you could ask a YouTube video a quick question, get a summary, or find a specific moment without watching the whole thing? Well, today I'm excited to show you how to build an agentic AI tool that does exactly that. Using AutoGen and Streamlit, we'll create a web application that lets you interact with any YouTube video. You'll be able to ask the agent to summarize the video, pinpoint when something happens, or answer all kinds of questions based on its content. I'm Mohammed, and I'd love to walk you through this step by step. Let's dive in and make it happen. Oh, and if you're into agentic AI, check out my previous tutorials. There's a bunch of cool projects you can build from scratch. Okay, so we'll be doing this project in 2 parts. In the first part, we'll develop the agentic side, the backend side, and then in the second part, we'll develop the UI, the web application with Streamlit. And in the first part, we want to have an agent that is an LLM and can use tools. We'll develop and provide some tools for that agent. These tools can extract the title, the description, or the transcript of a video, a YouTube video, and then the agent can get a question from the user and answer it based on those information. So let's start developing the agentic part. Let's call this agent.py. So we'll be working with AutoGen, the most recent version, 0.5, which is the stable version. And to extract the title and the description of a YouTube video, we'll be working with PyTube. And there's this library, PyTube. Let me show you. And it's pretty easy to work with. We have PyTube in Python. You can extract, you just need to have the URL of that video, and then you can extract the title and the description. But unfortunately, PyTube has recently developed, I can't say developed, but recently it has a bug. And whenever you want to extract this information, it fails and gets you a 400 error. So funny enough, there's a new library called PyTube Fix. They fixed this bug in PyTube, and you can just install it using pip install PyTube Fix, and it works pretty the same as PyTube. You just need to have the URL. You'll create a YouTube object, and you will pass the URL, and then you're good to go. So let's see how it works. Import PyTube Fix, and let me change my Python environment. Okay. I can say from PyTubeX import YouTube, and today I'll be working with this video. Of course, you can work with any video you wish, but this is a video of one of my favorite scientists, Rich Sutton. He has recently won the Turing Award, and it was very well deserved. If you know him, then you know what he has done in reinforcement learning, and I strongly encourage you to read his well-known book, Reinforcement Learning and Introduction. It's a seminal work in reinforcement learning. It's like reinforcement learning's Bible. So this is one of his recent interviews after winning the Turing Award, and I'm gonna use this video to test my application. Okay, so let's say this is my URL. I should enclose it with double quotes or single quotes. And okay, I want to extract its title. It's as easy as this one. We need to create a YouTube object, and we need to pass the URL. This is the URL, and now I can easily say, for example, yt.title or yt.description. Let's add an empty line between them. Okay, let me run this code. Python agent.py. Yeah, you see here's the title and here's the description. And there's another library in Python. It's called YouTube Transcript API. Let me show you. YouTube Transcript API. This one. You can also pip install this library, and then you can import it from YouTube Transcript API, import YouTube Transcript API. And unlike the PyTube Fix, it doesn't get the whole URL. It gets the ID of that video. And here's how you can get the ID. You know, this is just the website, and whatever comes after this v equals is the ID of your video. And whatever starts from v equals and before this and sign. So, you know, this is just about which time the video was at that moment that I created the link. But, you know, here you can get the video ID. So if I want to get the video ID, I can just say video ID equals url.split, and split with v equals. It means whatever comes before v equals will be, you know, one part, and whatever comes after it will be the next part. Or if we have multiple v equals in this string, they will all form a list, whatever comes in between them. So, oh, I need whatever comes after it, so I need this one. And then maybe there is an and sign. Sometimes there is, sometimes there's not, but to be on the safe side, I can say split whatever we have so far, split it with the and sign, and just keep whatever is before this and. So this means that we have extracted this one. And now I can just say result or transcript equals a YouTube transcript API dot get transcript of this video ID. And I can print that as well. And this returns a list of dictionary. If you can take a look at the documentation. It returns a list of dictionary, and each of these dictionaries has a text key, a start key, and an end key. Well, the names are self-explanatory. The text is whatever is being said at that moment. Start is what second in, as a float number, in what second does this text start, and then end is in what seconds does this text end in the video. You can also specify different languages, but the default language is English. So let's see. Yeah, you can see we have the full transcript here. We have a list of such dictionaries, each dictionary having a text, a start, and a duration. So it doesn't have end. Maybe the documentation is not the most recent version. Okay. So this is how we extract the title, the description, and the transcript from a video. And by the way, if I wanna, keep it this way, there will be a problem. This is a very long string because for not only we have the transcript, but we have these additional text, this text key, this start key, this duration key. Maybe I don't really care about it. Maybe I don't want to consider the time properties of this transcript. Maybe I just want the text of that transcript. So in that case, this will be extra information. First of all, it can cause some LLMs to hallucinate. Of course, nowadays the LLMs are really smart. Maybe this might not be the case for many of them. But apart from that, this means that we will transfer, we will send more tokens. So this will cost more for us. So maybe we really don't need all this information if the question is not about the time properties of the transcript. So in some cases, we can just have the whole text all together as a single string, not as a list of dictionaries. So to have just the transcript text, I may call it transcript text. I can use the join function. So I can extract all of the text keys, the values associated with the text in each of these dictionaries. So I can say item dot item with for the text, and for each item in res, this will be a list that only has those text elements of each dictionary. So I can print it so that we make sure everything is going as we wish. You see, here's a list of these texts, and I wish to join all of them together. I wish to seek all of them together. So I can use the join function in Python. I can say all of these texts should join with spaces. And now if I print it, I can see all of the transcript as a text. And everything works well. Okay, so this is how we can get the transcript text. And we've also seen how to extract the title, the description, and the time properties. So Here's my plan to develop the agentic part of the project. We will have a single agent. It will be an assistant agent object in AutoGen. If you're not familiar with that, don't worry about it. It's pretty easy and you'll master it once this video is done. And this agent has an underlying LLM, which will be OpenAI O3 Mini. And then it will also have two different tools. One tool is to extract the transcript with time properties. This is for questions that require, considering time properties. And then it will have another tool that only extracts, the transcript without any time properties, any time information, to save additional processes and costs. So let me wrap this few lines in two different functions. I may call the first function, and since this is an IO bound process, our processor is not doing the main task. We're just calling an API and we're waiting for that API to answer us. So in this case, the better approach is to use async IO. So I can import async IO. And if you're not familiar with async IO, don't worry about it. It's just about, not pausing everything in the program and just waiting for one function to execute. While waiting for some external resource to answer us, we can do other tasks. It may not be, really saving us in this project, but it's a good practice to develop your functions with async IO. And by the way, functions in async mode are called coroutines. And in the previous videos, we've talked about async IO in more details. You can take a look at previous videos, such as the one that we have several agents working to develop a code, or we have several agents debating, or we have our previous video, there are two agents that answer questions about a data set. Okay, so let me wrap this up into this coroutine. Async def get video transcript, and it needs a URL. I don't want to hard code the URL in the function, obviously. So let me just move these into this function scope. And okay, we should have the title. Title will be yt.title. Description will be yt.description. And then we have this transcript text. And I can say the result will be, and let me rename this to transcript. And also I need to rename this. Okay, the result will be a string like this. Title will be title, and then in a separate line we will have description, which will be description, and then we will have transcript. Okay, and we will return the result. So just to make sure this function works well, I can create an event loop. We need an event loop to run coroutines. So if name equals main, I can say async IO, and let me paste the URL. Async IO.run. This command creates an event loop and runs the coroutine. Get video transcript with this URL. And then I can, store it in res, and I can print res. Okay, we have the result here. You can take a look. We have title, we have description, and the transcript. And in order to help the agent recognize this function and its use case pretty well, we can add documentation for the function. So it gets a URL, gets the URL of a video and returns the title, description, and transcript. And this URL will be a string, and the function will return a string as well. So this way the agent can use this tool more effectively. And I will also create a similar function, a similar coroutine, get video transcript with timestamps, maybe something like this. Again, it gets a URL, a string, and it returns a string. Everything will be pretty the same, but it will just return the transcript instead of transcript text. So let's say gets the URL of a video and returns the title, description, and transcript with timestamps. Fair enough. So these are just like what we've done. And here's the transcript, and then the res will be using just the transcript with time properties. Okay. And this will use transcript. Okay. So I can call this function now. And yeah, you can see we have the time properties as well as the text of the transcript. And by the way, I could have done this with just one function. I could have had another argument that return time, which might be true or false, and that is another approach. You can go ahead and develop the same project using that approach. The only reason I'm doing it this way is that I want to show you how to make the agent use two different tools. That's pretty straightforward, but maybe this is a good time to show how to use multiple tools. Okay. Now I have these two coroutines, these two tools, and it's time to define the agent. Just like previous videos, I would say from AutoGen agent chat.agents import assistant agent, and our agent needs to access an LLM. For that reason, I will import OpenAI chat completion from AutoGen x.models.openai import OpenAI chat completion client. So we'll have another coroutine, async def, let's say query. Yeah. And this coroutine gets a URL of a video and a query, which is a question that the user is asking. And okay, so let's define the agent first. Agent equals an assistant agent, and we need to select a name for this agent. The name will be YouTube video proxy, for example. And we need a system message. System message will be you are a helpful assistant. You will get the URL of a video, a YouTube video, and the user will ask questions about that video. You can use the tools to answer the user's questions. If the answer to that question is not in the video, because sometimes the LLM might think that it has the answer, but the answer is not really in the video. I want to prevent this situation. You should say that you don't know the answer. Fair enough. Okay, and we need to specify the tools. So as you can see, we have a tools argument, and it should be a list of base tool object. This means any tool that is defined for AutoGen. Coroutines are considered as a tool as well. So I can pass the get video transcript and get video transcript with timestamps. And in the end, I need to specify which model, which LLM is it going to use. So let me define the model before the agent. Model will be OpenAI Chat Completion Client. The model will be O3 Mini. And I need to provide an API key. So I have my API key in this text file. If you don't have your own API key, you can easily head to platform.openai.com and let me log in. Inside the platform, you can go to settings, and we have the API keys here. You can easily create new secret key, but please make sure you don't reveal it, you don't, publicize it. You shouldn't push it to your GitHub repo. So it's safe to just, have it in a separate file, because you may have several API keys. My suggestion is that you can have a separate text file, or API.key or .text, and you can just read it inside your program. So open API.text, read it and strip it. Please make sure there's no extra space at the end, and pass this model to model client. Okay, so we have the assistant agent now. Now it's time to call this agent to see if it works or not. So for an assistant agent, we have this onMessages method. Let me show you in the documentation. AutoGen documentation. By the way, I insist again, this is a very important skill to be able to read the documentation, and this can help in many different ways. One of them is that you can find answers to your questions from the main source, which is the documentation. Or even if you don't have any specific question, it's usually beneficial to just scroll the documentation. Maybe you can learn something new. And I myself find it really helpful to regularly check the documentations for the libraries I frequently use. So we need to go to agent chat part of the documentation. Here's the agents page, and here's the assistant agent. And by the way, assistant agent is derived from base chat agent. So you can see we have an onMessages and onMessages stream methods in this base class in base chat agent. It's just like the run and run stream functions for a team. Here we have onMessages and onMessages stream. And if you just call the onMessages, it will return, as you can see here, it will return the response. But onMessages stream is an async generator. It will return every dialogue, every message once it's there. So this is a better solution if you want to show in somehow a real-time manner, if you want to display the chats in a real-time manner. So let's use this one. And this is documentation. You can see for onMessages stream, you need to pass a messages which will be a sequence of base chat message. And you also need to pass a cancellation token. A cancellation token is an object that you will pass to this method. The advantage of using cancellation token is that sometimes you wish to cancel a process while the agent is trying to come up with the answer. So in that case, I'm sure you've seen, for example, in ChatGPT, there is this square button. Whenever it's trying to generate the response, you hit it and everything stops. That is what cancellation token is for in AutoGen. So we need, and since the onMessages stream is an async generator, we need to iterate over it. So we need an async for message in agent.onMessages stream, and now we need to provide the messages. It will be a list of base chat message, and the class of messages that is usually being used in AutoGen for chats between agents is text message. We've seen it in previous videos. So let me import the text message object from AutoGen agent chat.messages, import text message. And I also need to import the cancellation token from AutoGen core, import cancellation token. Okay. So I will create a text message here. And the text message needs a source and content. The source will be user here because this is coming from user. And the content will be the query that the user is asking. But let me call it task for now. And I will create task before this for loop. Because I don't want to just include this query, I also want to include the URL of the video, and then the agent having that URL can call the tools and get the transcript, the title, the description, and answer the question, the query based on those information. So I would say this is the URL of the video URL, and then we will have the query. Okay, so we have the first argument now. We have a list of messages. It's just one element, one message there. And then we need to provide the cancellation token. So cancellation token will be a cancellation token object. And for now, I will just print whatever this message is. We can then inspect it and see what different kinds of objects we have. Let me clear my terminal, and okay, we have this query now. This is my URL and this is my query. Summarize the video in 2 sentences. Okay, and now I will run the query with URL and the query. Maybe I can, to avoid namespace pollutions, I will name it a different thing. Query agent. Or maybe I can say ask agent. This is better. Now I will call this coroutine. Okay. Let's see. Okay, so an extremely ugly output. Well, we have the source here, and then we have a function call. You can see we have a function call. So we have different messages separated by new lines. So this is the first message. It is a tool call. You see, it's coming from YouTube Video Proxy, our agent, our only agent, and the agent has requested to call this tool, to call the get video transcript with timestamps. This is not correct because our question is not concerning the time properties. So ideally it was supposed to just call the get video transcript, not the with timestamp version. I can also specify that after this. But you see it got the transcript. And we have no further message here. So we don't have the final message here. The reason is that we have this argument whenever we wish the agent to use tools. It is called reflect on tools. Reflect on tool use. So it is by default none or false. This means that we will have no reflection on the tool output. But if we set this to true, after calling the tool, the agent will also, use the LLM to somehow process that output. So I need to set this one to true. And I need to explicitly declare for the agent that whenever the question is not about time properties, you should just use the first coroutine, the first tool, get video transcript. And when the question is about timestamp, about time properties, then you need to call the second coroutine, the second tool. Okay, so let me declare it here. If the question needs to consider time properties, you should use the get video transcript with timestamps tool. Otherwise, you should use the get video transcript tool. Fair enough. And for better visualization, let me insert some, some dashes between each message. Okay, let's have 50 of these, and let me clear the terminal and let me run it again. Okay, so now we have this function call. It is called, you can clearly see, it is called get video transcript. This is the correct usage. We have the output of the tool here. And then we have the response. And the response has the response object has a content, which is the final answer. You can see in this video, Rich Sutton, a Turing Award winner, engages in a reflective conversation with Cam Link about the evolution of reinforcement learning, emphasizing the foundational idea of learning from experience through rewards and penalties. They also discuss the importance of humility, continual inquiry, and challenging established norms in science to drive meaningful breakthroughs in artificial intelligence. This is a really good answer. And then we also have the inner messages that was used, inside the agent. This is essentially the same as what we had earlier, what we saw, above the response object. But, we have this response object once the agent is totally done. But when it is progressing and it is, calling the tool and getting an answer, you see, we have just different types of messages. So, okay, if I want to just extract the final answer, I can easily say, I can use the chat message, and then the chat message is a text message. I can access its content element. As you see, these internal messages are pretty ugly. First of all, I would like to see if the agent has called the tool. I would like to see which tool and what were the arguments. This is totally good. But I don't want to see, for example, the whole output. This is just too much. I don't want to see this long transcript. So I can also process these messages, these inner messages, just to see what types of objects they are. Let me also print their type instead of their content. So if I call this once more, if I run the app once more, okay, you can see these are different objects. We have a tool called request event, we have a tool called execution event, and then we have this response. And you can see how to import them as well, because we need to check their types and behave differently based on their types. So I would say from AutoGen agent chat.messages import, I had it earlier. I need to import tool call request event and tool call execution event. The request event is when the agent is gonna call the the tool, and the execution event is for when we have the result from the tool. Okay, so I can also check the documentation for these objects. Agent chat messages. We have tool request event and tool execution event, and they have content, they have type, they also have a toText method. It converts the message content to a string only representation that can be rendered in the console. So print message dot to string, to text. This is much better, but let me see. Yeah, this is much better, and we have an error because the response object doesn't have a toText method. So I can check for this. If message is an instance of response, and how can I check the response type? I can see it here. This is the response object. I can import it this way from AutoGen agent chat dot messages dot base dot chat agent dot response. Import response. Okay, now I can check if message is an instance of response, then just print message dot chat message dot content. Otherwise, it will be a function call, a tool call. So just print message.toText. And between each two consecutive messages, I want to print a bunch of dashes like this. Let me clear the terminal and run it again. Okay. You see we had a function call, and then here's the result, and this is the final answer. Okay. And that's it. And we have a none here. You can think about this, why we have a none in the end. First of all, do you think it comes from the agent? I mean, the agent has returned a none at the end of its response, or is it coming from somewhere else? The answer is right now on the screen. So I encourage you to think about it, look at the code you're seeing right now. But you can maybe you can pause the video and think about it. If you really think about this for a minute and you cannot figure out this none, then go ahead and see the rest of the video. Otherwise, I encourage you to pause here for a minute and really think about it. And if you know the answer, congratulations. You have a very good understanding of how Python works. The reason for having this none is that, I've returned the result of this, event loop, which is, running this coroutine inside the res. And you see in the coroutine, I'm not returning anything. So it will return none in the end. And this means that res will be none, and when I say print res, it will print none. So if I execute this again, there will be no none in the end. Okay, you see. So now we have a quite working backend. The agent can really respond to our questions about the video. Let me just try it with some other queries. For example, I may say, does he mention any of his former students? And let me clear and run it again. I haven't watched this video yet, so I really don't know the answer. It has called the with timestamp function. Not a very good use of the tools, but let's see. I looked through the transcript and I didn't find any explicit mention of his former students in the conversation. Okay. And what can we do to prevent this from happening? I don't want it to use the timestamp version when the question is not about time properties. Maybe I can change the system message and make it more clear. If the question is asking when a particular event is happening, you should use this one. Otherwise, you should use the other tool. Okay, let's see now. Okay, this is the correct usage of the tool now. And the same final answer. I checked the transcript and did not find any mention. Could you clarify if you meant a different part of the conversation? No, it's what I meant. Okay. So let me ask another question as well. Does he mention any of his former colleagues, or maybe any of his colleagues? I hope the answer is yes. Yes, he does mention some of his colleagues. For example, he talks a lot about his interactions with Andy, including a conversation they had after finding out about the award and so on and so forth. And also we have a manual here. Okay, so maybe I can ask, I just want to test this agent. I want to see how good it is. And this is really interesting to me. Tell me all the times that he talks about Andy. Now the agent should call the tool with timestamps. Yes, you see. Good. Okay. At 26 seconds, when someone says, oh, and make sure Andy is there, at 70 seconds, when he asks, what's that conversation with Andy after you guys found out? And a bunch of, more timestamps. I don't like this kind of reporting times. I wanted to report in the standard format. Let me also specify this in the system message. When you are reporting a time in the video, you should use the format, this format. And let's ask the same question again and see if we have improvements. Okay, this is great. And let me play the video and see if these results are actually valid. So for example, it says that at 26 seconds, he mentions, oh, and make sure Andy is there. Let me check.
And, I've
26.
Somewhere near the end, she said, oh, and make sure Andy is there.
Good. And for example, at 5:36, when he recalls that Andy and I have been like a fixed point, let me see. 5:36.
Andy and I have been like a fixed point.
Good. So now we have a working backend. The agent can really answer our questions about the video. And one last check, let me also check. Let me ask a question that does not exist there. Does he mention Lionel Messi? Okay, I didn't find any reference to Lionel Messi in the transcript. Okay, fair enough. So it's now time to develop the front end side. So let me create a new script, app.py. We'll be working with Streamlit like the previous videos. Import Streamlit as st. Okay. So I like to create a minimal UI. So let's say we have a title, chat with YouTube videos. Okay. And then I need a text input to get the URL. So URL will be st.text input. Enter the URL of the YouTube video. And let's see what we have so far. Streamlit run app.py. Okay, chat with YouTube videos, and here's the URL. Good. And just like previous videos, I need a container to display the messages inside that container. So I would say chat container will be st.container. And I also need a chat input element to be able to get the prompt from the user. So prompt will be st.chat input, and the placeholder is ask a question about the video. Okay, this is enough. And for example, just to show you the logic, I can say if prompt and URL, meaning that if both prompt and URL were there and the user had entered something for each of them, then with chat container, inside this container, just write down, I can even display the exact prompt for now. So let's run the code again, and this might be any URL and this might be any prompt. Let's say prompt. Okay, and you see we have it here. So the only part remaining now is to connect the backend to the front end. So just like the previous videos, I don't want to do all my backend stuff in one coroutine. I want to have a separate coroutine or a separate function to create the agent and a separate coroutine to orchestrate the agent. So let me move these two statements, model and agent definitions, into a new coroutine. I will call it config agent async def config agent. It doesn't get any argument, and in the end it will return the agent. And inside, and for the ask agent coroutine, I need to get the agent as the very first argument, and then the URL, and then the query. Everything is all right here. Let me have a main coroutine just to be able to make this agent.py script standalone, make it work even without the UI. So we have a main with the URL and a query. And inside this main, I would say agent equals await config agent, and then ask the agent to answer the query based on the URL. Okay, and when I'm creating the event loop, I will run the main coroutine. So let's see. I expect the agent to run smoothly. Agent.py. Okay, you see it's working. And by the way, I don't even need this config agent to be async because it's not an IO bound process. I'm not waiting for any input output. I'm just defining it myself. So and it's pretty fast, and I'm just calling it once. So for all these reasons, I can just define it in synchronous mode, and this needs to be called just in the regular way. Okay, so this code should work again. Let me ask a more meaningful question like this one, just to make sure the code works. Yes. Okay, so now I can import these two functions from agent, import config agent and ask agent. And I also need to import async IO. It's better to move this to the second line. So now I can, whenever a prompt is entered and we have a URL, I need to create a separate event loop, and in that event loop I will run this coroutine, this ask agent, to provide the answer to the prompt. So let me define this coroutine. I would say async def, let's call it main. It gets the URL and the prompt, and well, it will create an agent, and then it will ask the agent to answer the prompt, the question, based on the URL. And this is fine, but again, just like the previous videos, I can continue doing it this way and everything will be fine. But I wanna, access each message at the same instant that the message is created. I don't wanna, access all of the messages in the end. I don't wanna wait a lot. So one thing I can do is that instead of having the coroutine like this, I can make it an async generator. Instead of just printing it, I can yield it. So I can call this a message, and then I can yield the message. Okay, and the same goes on here. So this will be a message, and I will yield this message. Okay, so here's what we have, and now I need to iterate over this generator, this async generator. I can say async for message in ask agent, and here I can process each message once we have it. So in the most basic way, I can just say with chat container, inside our chat container, st, and just display it as a message. So with st dot chat message, and the message is coming from the assistant or AI. st dot markdown, render it as a markdown message. So this should be working fine. I can also, and I need to create an event loop from this one, like this, async io.run main with URL and prompt. And I can also put this inside a spinner object, st.spinner, generating response. Okay, so let me run the app now. I need to copy the URL, and I can say summarize the video in one sentence, generating response, and let's see. Okay, so you can see the problem. It's working, but it's extremely ugly. So we have a function call here, and this is the function called result. It called the get video transcript, and then this is the result. And after we have the result, we have this response object. And, inside this response object, the final answer is in chat messages, the content. So the video features Turing Award winner Rich Sutton engaging in a candid conversation with Cam Link about the evolution. Okay, so we have the result here, but this is extremely ugly, and I don't want to, do it this way. So let's modify the UI to make this better. First of all, instead of yielding the string of the message, it's fine for the final message. I like to do it this way. But for the inner messages, I don't like it this way. I don't want to yield a string. Let's just print the string, the to text. But when I'm gonna yield it, I will yield the MSG instance, because this will be a different class other than string, and then based on the type of the class, I can behave differently in my UI. So I will go to app.py, and now I need to decide what to do based on the type of each message. And I would like to introduce a new function. I will call it show message. It gets a chat container object and the message, and based on what we have, it will render the message differently. So I would say with chat container, okay, if message is a string, if is instance message and string, this means we have the final result. So just render it as a chat message, with st.chat message from assistant, or it can be AI, no difference. Render it as a markdown. And otherwise, else, this means that the object is not the final result. Else with sc.chat message from again AI, but I would like to just render message dot to text, and I would like to render it. I don't like to do it this way. Okay, let me put it inside an expander object. This is just, I'm sure you've seen this element. This is one of the elements that can be collapsed or expanded, and the label will be inner message, something like this. So let's see what we have. Let's run it again. So here's the URL, and here's my question, summarize in one short sentence, generating response. Oh, sorry, I forgot to call this show message. So whenever I have a message, instead of rendering it here, I would like to call the show message function. And I need to pass the chat container and the message object. Run it again. Here's the URL and here's my prompt. Summarize in a short sentence. Okay, you see, we have an inner message, we have another inner message, and oh, okay. We have an error, and you can see the error here. By the way, it is extremely important to be able to, read an error effectively and figuring out what's going on and how to solve it. So it says that response object has no attribute to text. What does this mean? This means that, we had a function tool call, so we could handle this object effectively. And then we had another object. This is, the result of that tool. Again, this is fine. And then we had a response object apparently. And, we called the toText for that response object. So I may need to specify the condition. I don't want to render the response object, so I can just easily say, first of all, I need to import the response object, or those two other objects, those two other classes, tool call and tool call request event and tool call execution event. So I can say import these two, and inside my show message, instead of saying if this is a string, do this, else, use an expander, I can specify the exact condition. Elif, it is an instance of a tool called request event, use an expander and say tool call request, something like this. And if it is a tool call execution event, have an expander and say this. And this way I will not bother with the result object, the response object. So let's run the code again. Let me copy the URL. And here's my prompt. Summarize in one short sentence. We have a tool called request, we have a tool called execution, and oh, it didn't render the final result. Let me see why is that. So if it's a string, do this one, and we're calling this for almost, for all of the messages. So what might be the problem? I must have forgotten something. This is a very good moment to think about it, and you can also, think about it if you don't already know what's going wrong. So let me inspect this agent, and there must be something wrong here. And there is something wrong here. I need to return a string here because, whenever it is my final response object, I want to just return the message, the chat message, the content. I want to return the final answer, not the whole response object. So this should be working now. Let me check it one more time. This is the URL, and summarize in 3 words. Let's make it challenging. Okay, we have the final answer here. Based on the discussion's emphasis on the central role of learning from feedback and working together without a fixed authority, a 3-word summary could be experience fuels discovery. This is nice. And now we have a working UI. You can chat with it. You just saw how it works. But I'm not satisfied yet. There is 1 or 2 more things I can do to improve this application. So think about it. What do you think is, the main things I can do to improve this one? And what problems do we have right now? Of course, we can chat. You saw, we can chat with the video. We can ask a question and it will answer. But there are, again, 2 problems with this version I would like to address. To show you the problems, let me do it this way. What did I just ask? Okay, you saw the problems, both of them at the same time. First of all, our previous chat has disappeared. We have no longer access to it. We don't like this. We want to, see all of our previous chats. And secondly, you provided the YouTube URL and then asked, what did I just ask? So this isn't the correct answer. This shows that the agent doesn't have memory, and of course it doesn't have memory because I'm creating the agent each time I have a new prompt. I call this coroutine. It creates a new agent, and the agent provides the answer. So it doesn't have memory. So what can I do to overcome these 2 problems? Well, to keep the previous chats, I can have, a messages list. And once I have any chat, I can append it to that list. And initially, I can display all of the previous chats. So let's do it. We have st.session messages. And the whole point of session messages in session state in Streamlit is that, the logic of Streamlit works as whenever there is an event on the web application, whenever you click something or a text changes, it runs the whole script from the beginning to the bottom. So we need to take care of this logic when we're developing Streamlit applications. And well, this is the logic. And the whole point of session states is that they are kept and they are, retained across different renders, different executions of that script. So I can check if we already have, then I don't bother. But if we don't have messages, I will create a new list and, store it as messages. So if messages not in st.session state, then I will define st.session state.messages as an empty list. And whenever I have a new message, I will append it to session state messages. So I will say st.session state.messages.append message. And I will show it immediately. But before processing the prompt, I would like to display all the previous chats if we have any previous chat. So I would say for message in st.session state.messages, show that message. Just as simple as this, because we already have a show function here. Okay. So if I run the application now, the first problem should be fixed. So here's the URL and summarize just one simple prompt. it had a tool called request, and this is the summarization. And if I ask a second question, for example, who is the main character? Now you see, my previous messages are still there, even after answering this one. Based on the transcript, the main character is Turing Award winner Rich Sutton. I still have my previous messages. But we still have the memory problem. What did I ask at the first place? You see, it doesn't know it. The very first question you asked in the video was essentially, thank you for coming. Oh, it it thought that I am the interviewer. Okay. So you see, it doesn't have memory. So how can we keep the memory? You know, we have the messages, we have the history of messages to visualize, but the agent really doesn't have the memory. So there are several ways I can pass the memory to the agent. One is to keep track of the memory myself, and whenever I am calling the onMessages stream, you see here, instead of just passing one user prompt, I can pass all of the previous history, and this way the agent knows exactly what is happening. Another way to keep the memory is that I can define agent outside this coroutine. But the problem is that, you know, these agents in AutoGen, they're bounded to an event loop, and once I want to, you know, create a new event loop using async.io.run, the agent is lost, and you know, I cannot, it will produce an error. So I can solve that problem as well. I can create a single event loop at the beginning and always use that one. Use the run until complete method in async.io. If you're familiar with that, please go ahead and do it that way. This is a really good practice. But I want to do it in a more agentic way because the agents have methods to load and save state. So let me do it that way. So whenever I'm done with the agent, I want to save its state as a session state variable. So I can say, you know, after this is done, after the coroutine has been executed, I want to return the agent dot save state. So this will return the agent state for me, and I will keep it as agent state here, and I will save it as st.session_state.agent state. Okay, and then once I've created the agent, I would like to check if I have a previous agent state. I would like to load that state. So if agent state in st.session state, agent.load state, this agent state. Okay. So I believe this should fix the problem. Let me check. This is the URL, and I would say summarize in 3 words. The agent is calling the tool. Experience, ambition, humility. Good. And then now I can ask, what did I just ask? You provided a YouTube video URL and then asked, what did I just ask? Okay. What was my very first question? It has called the tools. It's a little bit strange. Your very first question in the video was when you said, can you tell us how you found out? Oh, it's again mistaken me with the interviewer. Let me see if everything is all right here. Let me check the code, and then maybe I'm testing it in the wrong way. Okay. If we have agent state, then load it. And once you're done, then save the agent state as agent state. And it seems that we're good to go. Oh, we have errors, right? Yeah. We have errors here. Okay. Oh, these are async methods. I should await them. So let me say agent state equals await agent.saveState, and then I will return agent state. And then once I want to load it, I should also await agent.loadState, this one. So let me check and see if everything's fine now. This is the URL. Does he mention any of his colleagues? Yes, he does. For example, he talks about getting a phone call where someone said, make sure Andy is there. Okay. Who is the first colleague? Who is the first one you just mentioned? Okay. Let's see if it can answer this one. I'm expecting it to answer it's Andy. Yeah. The video transcript only tells us about that he was told to make sure Andy was present. What was my first question I asked about this video? Yeah, does he mention any of his colleagues? This is correct. And one other problem we have right now, I just figured this out. We're not displaying the user's prompt here. So let me also add the user's prompt as well. So whenever we have a prompt, I would like to, first of all, show it and then add it to the messages. So if we have prompt, I would say append it to the messages, but you see, poor suggestion from Copilot. Append the prompt and show message, the chat container, and the prompt. And for this prompt, I would like to show it differently. So I would say append this one. Append user and then the prompt. Okay. and then show this one. And inside the show message function, I would say initially check if, if it's a string, then check. If it starts with user, then you need to render it as a user's message. Otherwise, you need to render it as AI's message. Okay, this should be fine. Let me see. This is the URL. Oh, okay. This is the URL. And who is the main character? You see, this is our message. The main character is the Turing Award winner, Rich Sutton, who is the colleague he mentions a lot. For example, the colleague he mentions a lot in the video is Andy. Good. And who is Andy? Let's see if the agent answers. What do you expect? Do you expect it to answer or not? The video doesn't explicitly give Andy's full name, but however, based on the context and what is well known in the field, Andy is Rich Sutton's longtime research colleague. It's actually Andrew Barto. Yeah. So, and we have the user's message now. And one other thing, let me see if this works or not. My very first video in my YouTube channel doesn't have timestamp. Let me see if it can come up with a timestamp for that video. So let me go back to that video of text, but it doesn't know if it. Okay, this is my very first YouTube video. Let me pass it to our application and see if it can come up with a timestamp for it. So this is the video. Generate a timestamp for the main events in the video. Generate a YouTube timestamp. Maybe this may be better. Okay. It would be super cool if it can come up with these timestamps. And you see it has used the correct tool, the tool with timestamps. And okay, there it is. We have the timestamp, we have the introduction, we have scenario overview, multi-agent concept, code setup, agent initialization, critic agent setup, LLM configuration, and API key. Yeah, we have the main timestamps. Okay, so that's it. We have a quite working web application. You can chat with YouTube videos. You just need to copy the URL of that video and ask any question you have about that video. So I hope you enjoyed today's video. I strongly encourage you to go on and do this yourself. Try to be creative. Do it with other methods. It is really important to be able to start from scratch and develop a full app maybe in 1 hour or maybe even in less than an hour if you're a fast coder. And if you have any comments about this video, if you have any suggestions for the next videos, any topic you have in mind that might be interesting, please go on and comment it, and I will make sure to record tutorials on the interesting suggestions. So that's it from me, everyone. I hope you enjoyed it, and take care. Imagine automating your entire literature review with AI in seconds. I'm gonna ask our agents, for example, find 5 new papers on diffusion models for image generation. One agent searching archive for the latest publications. And here's our researcher agent summarizing each paper's problem and methodology. Hey everyone, I'm Mohammed. In this hands-on tutorial, you'll learn how to build this powerful web application from scratch using AutoGen and Streamlit. Ready to supercharge your literature surveys? Let me show you how. Drop your questions below and don't forget to explore the rest of my Agentic AI tutorial series. Okay, this is an interesting project to myself because looking for new papers or relevant papers in a field is usually so time consuming. And other than that, even if you find the papers, it is usually not straightforward to get a good big picture about that paper. You know, what problem they're trying to address and what is their method, how are they addressing that problem. And if you know this stuff before starting to read the paper, you have a way easier job to read the paper and understand it. So that's exactly what we're gonna do today. We're gonna have 2 agents. One of them goes and searches in archive and finds the best or the most relevant papers. And the other agent extracts the problem that those papers are trying to solve and their methodology and so on and so forth. So we have 2 agents. One of them searches in archive and the other one generates a report. And in the end, we're gonna build a UI just like the previous videos with Streamlit. That would be super simple. And the main part of this video is to come up with the agents. Okay, so let's get started. We will start with agents.py. This script has the agents and the team of those agents and how to orchestrate those agents. And then in a separate script, we will develop the UI. And just like previous videos, we'll develop this project with AutoGen, the most recent version of AutoGen. So without further ado, let's get started from AutoGen agent chat. First of all, let's import the agent. From AutoGen agent chat.agents, import assistant agent. And I also need to import async IO because the methods I'm gonna use from AutoGen are all async. So I need to create event loops and coroutines to make them work. So let's say we have, for now, an async main coroutine. And now time to create my archive agent. I call it archive agent. It is an assistant agent. And well, I need to specify its name. The name will be archive agent and a system message. Let's say this is a system message. You are an agent or a helpful assistant that gets a description from user and searches for the most relevant or newest papers on archive. We'll use archive Python API. You know, archive has a HTTP API and then we have a Python module that is actually a wrapper over that API. So we'll use that module. I will explain how it works momentarily. On archive using the archive API. Using Python archive API, let's see. Okay. And let's say the user specifies search for 5 most relevant papers. Well, I don't want to just search for 5 papers. I want to search for, let's say, 10 times more or 5 times more papers. And then the agent chooses what are the best 5 out of them. So always search for 5 times more papers than the user requested. Okay. And this agent will have a tool. We will build a tool momentarily. That tool is actually the tool to search archive. So I should also instruct that as well. Use the tool provided to conduct the search, craft the query, because archive has a structured query to search for the papers as well. So craft the query in archive API format. Okay. We'll see what I mean by this one. So this is also the system message, and we need to provide a model client. This is just the LLM behind this agent. So for that, I need to import ChatGPT chat client completion. So from AutoGen extensions .models.openai import OpenAI chat completion client, and I need to introduce the model now. Model will be OpenAI chat completion client, and the model is, let's use O3 mini, and the API key is in API.text. Open API.text.read.strip. So in the previous videos, I've explained how this works and how to get your APIs. It's super simple, and if you don't know it yet, well, the best method I suggest is to search in Google, and after that, or even in another method, you can also watch the previous videos. Okay, so model client will be model. And now it's time to build our tool. So before that, let me show you the archive API. So we have an archive API just like this. You know, in the official website of archive, you can see we have some information about the API, and the API is actually in HTTP GET and POST methods. Let me see where, API basics or API user manual. And this is how it works. We can see the Python example. You can just, send a POST request, and this is its structure. HTTP export.archive, and you need to specify the query. For example, in this example, they said, okay, search in all different fields. I mean, the title, the authors, and so on and so forth. Search for electron. And, this start means, whenever we conduct a search, let's say archive sends back 100 results, 100 papers. It says start from the beginning and just go to the number 1. It means that just return 1 paper for us, and in the end print the result. But this is simple enough, but we have a better way of doing this, because some guys have made our life easier. We have a Python wrapper for this, Python archive API. Yeah, that's it. You just need to pip install archive and then you're good to go. And you don't need any API key or whatever for this API. And this is the syntax. You just import it. You create a client and you create a search object. You say, okay, this is my query. How many results do I wish? And how to sort them. Do you want to sort them by submitted date if you want to search for the newest paper? Or you may want to sort them by relevance. And this is the result. And then you can iterate over the result. So let's create a function. I may call it search archive. And it gets a query, which is a string, and max results, which is an int, and the default value may be 5, fair enough. And also sort by, which is a string, and the default value may be the relevance. Okay. And it's actually a good idea to have a documentation for the tools as well, because this is the most effective way to inform our agent what is this tool and how it works. Okay, search for papers on archive using the archive API. And I can also specify the arguments, it's fine. On the search query, the maximum number of results to return and sort by. Okay, and it returns a list, a list of dictionaries. That is actually what I was thinking to return. We will have a list, and each item in that list is gonna be a dictionary, and that dictionary contains the title, the author names, and the summary and the URL of that paper. So a list of dictionaries containing papers information. Okay, fair enough. So let me import archive as well. Import archive. Now time to create the client. I would say client equals archive.client, and now the search object archive.search. Query will be the query that we have as the argument. Max results will be the same, and the same for sort by. And now we have the results. Result will be, let me check the documentation. Client.results of search. Client.results of search. And now I will say papers will be an empty list. And for, let's call it result. And for res in results, paper.append, papers.append actually. Okay, this dictionary. Title, summary, fair enough. Summary is just the abstract of the paper, the author's name, and as you see, this is how you should get the author's name. It returns some author object, and you must say author.name. For author in res.authors. And I don't want to include the published. How about the URL? Res.entry ID. Okay. This is not the URL I wish. This is just the entry ID, the ID for that paper. It should also have a URL. PDF URL. That's what I was looking for. You see, Copilot can make our life easier because instead of going over the documentation, it can make good suggestions, but never trust it blindly because, well, in modules like archive, it has been trained on very well, but for other modules like the newest versions of AutoGen, it has no clue what it's doing. It just comes up with some hallucination most of the time. So don't trust that. Okay. And in the end, just return papers. And to make sure I have what I wanted, if name equals main, I would say my description is find 5 most relevant papers, or sorry, this is not how it should work now, because I just want to test the tool. So the query will be GAN, for example. I just want to search for papers in GAN and search archive with this description, with this query. And in the end, print the papers, or maybe let's pretty print them. And from pretty print, import pretty print. Okay. Let's say Python agents.py. Yeah, we have an error. String object has no attribute value. Okay. So why is that? Because okay, so it says that the error is in this line for results. So apparently this line didn't generate the error. So the problem seems to be for this sort by, and it says that, because our sort by argument is a string, but I guess it is expecting something else. Let's take a look at the documentation. Sort by, where's sort by? Yeah, okay. This is an archive enumeration, so let's do it just like the documentation says. Instead of a string, I would say archive.sort criterion, and then the default value will be archive.sort criterion.relevance. I guess now everything will be fine. Yes, you see. So this is the result. For example, this is one paper, and here's the summary, and here's the title: generative adversarial networks and adversarial autoencoders, tutorial and survey. And yeah, we have 5 different papers here. So our tool is working now, and we need to just pass it to our agent, to our archive agent. So tools will be the search archive. And this agent's answer doesn't just end after calling this tool. It should also do some process over the tool's response. So we have another argument, reflect on tool use, and by default it is false, but we need to set it true because as I said, after getting the response from the tool, I want my agent to process that response as well. And because I've said that whatever number of papers that the user asked for, you should search for 5 times more papers. So if the user wishes for 10 papers, the agent actually searches for 50 papers, and then it needs to select the top 10 out of them. So this is what I mean by reflect on tool use, because even after calling the tool, the agent has still some stuff to do. Okay, I guess this agent is done now. And now let's define the reporter agent or the researcher agent. I may say researcher is another assistant agent, and the name is researcher. And here's the system message. You are a researcher. Researcher agent. Based on the papers provided by the archive agent, you need to generate, and I wanted to generate its report in markdown format, because I can render markdown in my Streamlit app. You need to generate a markdown report that summarizes the papers. Initially, you need to generate an introduction that describes the research area, and then for each paper, you need to state the title, the authors, the link to the paper, the problem they are solving, and how they are solving it. Fair enough. I guess this is good for this agent. And the model client will be the model. I want to use O3 Mini for this agent as well. And now it's time to define a team of these agents. Just like the previous videos, we will use the round robin group chat, because the roles of these agents in our current project is deterministic. We know that, okay, first of all, the archive agent should do something, and after that we have the researcher agent. So from AutoGen agent chat.teams, import round robin group chat. Okay. So team will be a round robin group chat, and we need to specify the participants, archive agent, and researcher. And how many turns do I wish these agents to talk? Just one turn, because I want the archive agent to search once, and then the researcher to generate the report, and nothing goes beyond that. And now it's time to orchestrate the agents. For now, I can do it the usual way. Async for message in team.run stream. I need to specify the task, and the task will be I will get the task from the argument of this main coroutine. This is the task, and here's the task. Okay, I don't need this anymore. Task will be find 5 papers, 5 best papers on GAN for image generation. Okay. And then I need to create the event loop and call the main coroutine with task that I defined. Okay, so now I have a for loop, an async for loop over the messages of the team. And I can initially just print the messages, but it will be extremely ugly, and I need to take care of that as well. But for now, let's just say print, let's say some dashes to separate different messages, and then the message. And I can pretty print the message for now. You see, this is the user's message, and we have a tool called request with these inputs. The arguments are query is GAN image generation. Correctly, it has searched for 25 papers and sorted by relevance. And here are the 25 papers. It stopped because the maximum number of turns is 1. I should say it must be 2. So let's do it again, because, well, logically we have 2 turns, one for the archive agent and the second one for the researcher agent. Okay, so yes, here's the result, but as I said, it's extremely ugly, and here's, for example, the text message for the archive agent, but the whole dialogue is there now, and we just need to prettify it and make sure it is displayed in a beautiful way. So now we can start developing the UI as well. So let's create app.py, and just like previous videos, import Streamlit as SD and import async.io. And from agents, okay, just as we've done this in previous videos, I don't want to do all of these processes in just one coroutine. I want a separate coroutine for team configuration and another one for the orchestration. So let's split this into 2 coroutines, async, or it doesn't need to be async for team configuration because it's not an IO bound process. Def team config, and I will move almost all of these except maybe the last async for to this team config, and in the end I will return the team. Return team. And now instead of having this main, I would say orchestrate, and it gets a team and a task, and just like this, but we need to make sure it's behaving different kinds of messages differently. So we have different types of messages here. For the agents, textual response, they are text message in AutoGen. And for the tool, we have 2 different classes. We have tool call request and tool call execution. So let's import these classes and make sure we're treating each one appropriately. From AutoGen agent chat.messages, import we have text message, and we have tool call request event and tool call execution event. Okay, and now I can have an if statement. If message is an instance of text message, I like to print it this way. Print message.source column and then message.content. And if it is a tool call, called request event, I just want to print its toText method. It has a toText method for tool called request events. So I would say just print message.toText. And if it is a tool call execution event, do the same, print message.toText. And I will have a main coroutine just like before. And yeah, initially I need to define the team, and then I need to orchestrate that team. Let's see. And just like before, I will add some dashes to make sure that different messages are separated. Okay, we have a function call. You can see we have a function call. This is its result. And this is the final result from the researcher. Yeah. Okay. I just need one more modification to the current version of agents.py. You can see in orchestrate, we're iterating over the run stream messages, but we're not yielding it. It is currently a coroutine, but I want it to be an async generator because if I use it this way, everything will be fine, but I will have the whole conversation when the whole conversation is done. But this is not what I wish, because, for the UI, for the UX, for the user's experience, the user needs to see each message, as soon as it is ready. We don't want to make the user wait for 1 minute. We want to, make sure that the user is seeing every message once it is generated. This way it will have a more pleasant experience for the user. Okay. So instead of just printing it, I also want to yield this information, these messages. So I call this message, and I want to yield it as well, yield message. The same goes for tool called request event. This will be message and it will be yielded. And the same here, message, and I want to yield it. And now this main should also be modified. I need to iterate over it. So async for message in orchestrate team and task. And I don't need to do anything because I'm already printing it. So I just need to pass. Let's make sure this works as we wish. Yes, you see. Okay, you see it's working, and this is the archive agent's response, and after that we'll see the researcher agent's response. Okay, and here's the researcher agent's response. You can see. So now we're prepared to include this agents part, its agentic part, in our UI. So from agents, import team config and orchestrate. And our UI will be super simple. I just want to show you how to do it efficiently. So let's say sc.title to define the title. Literature review assistant, and then I need a description, text input, enter description of the research area or to conduct a literature review. Okay. And then I need a button, and I need to be aware if that button has been clicked on or not. sc.button, search, and its type will be primary because I want it to look red. And I also need a container to display the chat between the agents. So I will say chat container will be an sc.container. And if the button has been clicked on, then, okay, if we've clicked on the button, the following should happen. So we need to create the team, and then we need to orchestrate the agents. And once every agent returns a result, a response, we need to visualize it. So I would say, and I need to define an event loop for this as well, because, and also a coroutine, because our agentic part is implemented in async IO. So I would say async def main, and it gets a description, and inside the main I would say team. Okay, let's create a team, and then async for message in orchestrate team with the description. And now for each kind of message we should do a different job. So if the message is coming from the search agent, I want to visualize it differently with a different icon avatar for that agent. So, and for all the messages that are from the archive agent, you can see like here, it starts with archive agent colon. So I can say with chat container, I want to do it inside the chat container. And if message that starts with archive agent, then with sc.chat message, and for the avatar I would choose human. Let's display it because I just want to display it with a different avatar from the report, the researcher agent. So sc.markdown. This is a wise suggestion. It wanna skip the part, having archive agent colon, and let's do it. And if it is coming from the researcher, do it this way. See the chat and messages from 12. And it is funny. Is this really 12 characters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this should be 10. This was a correct suggestion, I guess. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Yeah. This was a wise suggestion, but you see, just because it at this stage, Copilot was also seeing this one, so mistakenly it chose 12 for this one as well. So never trust Copilot suggestion blindly. Okay, and else, what is else? Else is, we have these two different messages. What other type of message do we have? The tool called request and tool called execution messages. So for those cases, I want to create an expander object. So with sc.expander and call it tool call. Fair enough. Just, okay, yeah, display them in Markdown. And I guess we're good to go now. Let's see. Streamlit run app.py. Okay, this is the literature review assistant title, and my description, I would say find the 3 most relevant papers in diffusion models theory. Okay. And we have this one. We have this tool call. Oh, this is, yeah. We have a bug here. We don't want to display the user's message as tool call, but it's fine. So this is the user's message. And this is how the agent called our tool. You see, it correctly looked for 15 papers because I asked it to look for 5 times more papers than the user has requested. And okay, here are the papers suggested by our archive agent. And yeah, this is suggested by the researcher. You see, it has an introduction introducing the diffusion models research field and 3 papers. This is the title, this is the authors, this is the link, problem being solved, and how they solve it. Cool. So, first of all, this isn't rendered correctly. I want to make sure this is fine. And other than that, and why is this happening? Because we have a dot here. So I should make sure we don't get this dot as well. And also, I don't want to include the user's message as a tool call. So let's fix this. I need to have another elif message that starts with user, then do it like this. And I don't need to separate this actually, and for this one I need to start from 11th character, and I guess it will be good now. Now I can say find 10 newest papers on what? Let's say on LSCMs. And it will also be a good idea to have an spinner object here with sc.spinner and say searching. Yeah, do it this way, and once it's done, just say it's done, and maybe let's have some balloons as well. Okay, so this is the archive agent. And now we have the report generated from the researcher agent. These are some new papers on LSTM. Okay. And we can also search with, authors as well. I can say find the newest papers from Ilya Sutskever. He's my celebrity. Okay. And we have this searching now. And now you see the query has changed. It is just looking for all the authors, for Ilya Sutskever in authors field. And since I didn't mention how many papers to find, it went with 25. Okay. So these are the 5 newest papers from Ilya, apparently. And yeah, and we have a brief report for each of them. This can help you speed up in reading papers because, before starting to read the paper, at least you know what problem they're trying to solve and what is their approach. And so while reading the paper, you already know this, and it can help you assimilate the paper way better. Okay, so that's it. I hope you enjoyed it, and I strongly encourage you to do it yourself. Just start from scratch, try to write each and every line of code, and whenever you have an error, try to address it, try to solve it. Go and read the documentation, go and read their GitHub codes, and this really helps you to master this agentic AI emerging field and add it to your skills. As you saw, it is really straightforward and it gives you some superpowers if you compare these abilities with, let's say, 5 years ago. So please go ahead and do it yourself. And if you have any suggestion for next videos, please comment them for me and I will make sure to first of all respond and then use these ideas for my future videos. So I hope you enjoyed it. Until the next video, take care. By the end of this video, you'll learn how to build this agentic chatbot specialized for content generation. I'll show you step by step how to build 3 agents, a writer agent, a content critic agent, and an SEO specialist agent collaborating to provide a high quality piece of text. Okay, so today we'll be developing an agentic AI project in which 3 agents collaborate to provide a high quality piece of text. These 3 agents are a writer agent, which gets a description from the user and comes up with a draft or initial version of the text. And the second agent is a content critic agent. It scores the writing provided by the writer agent on grammar, on clarity, on style, and also provides a to-do list on how to improve the current version. And we will also have an SEO critic agent. It gives us a score on the current version of the writing from the SEO aspect, and also some to-do lists to make it more SEO friendly. We'll be using the most recent stable version of AutoGen, and we will create a team of these 3 agents and we'll orchestrate them to accomplish our desired task. And in the end, we will develop a very simple UI, a web application using Streamlit, just like the way we've done in previous videos. And from a developer's aspect, here's what we're going to do today. We will define assistant agents in AutoGen. We will work with OpenAI O3 mini LLMs. We will create a team out of these agents. More specifically, in previous videos, we've done this using the round robin group chat. That is one very effective way to create teams out of agents. But today, just for the sake of learning, we will do it differently. We will create a selector group chat. I will talk about the differences between the round robin and the selector group chat. We'll also create a custom data type that the agents will generate their output in that structure, in that data type. So instead of making the agents, just generate some arbitrary text, their output will be more structured. We will tell them what structure to use for the output. And then we'll develop a custom termination function. If you watched my previous videos, you'll see that we've used some predefined termination conditions to terminate an ongoing chat. But today we'll be developing a custom termination condition. This is a little bit advanced in AutoGen, and we'll see how we should do that. And last but not the least, we will develop a UI, a web application using Streamlit to showcase our project. So without further ado, let's start. Okay, I'll create a writer.py for my agentic side. The 3 agents will live in this script, and I will make the team out of these 3 agents here, and I will orchestrate them here. And then I will have a separate app.py to develop my Streamlit web application. Okay, so let me define the agents first. Just like my previous videos, from AutoGen agent chat.agents import assistant agent. And just as a quick definition, assistant agent is a class to represent an agent that has an underlying LLM and also can use tools, can generate outputs in our desired structures. It can get a system message to know what is its role and how it should do its role. And we will use async IO to develop our project, mostly asynchronous. And we'll use async IO to develop our project, mostly asynchronous, whenever we can. This is a common practice nowadays in developing agentic AI projects. So import async IO. Okay, so let's define a coroutine. I will call it for now main, a main coroutine. And this will be our writer agent. I would say writer agent equals assistant agent. The name will be writer agent. And I need to specify the system message. So for the system message, I would say you are a writer agent. You will be given a topic and you need to write some content about it. You will be collaborating with a content critic agent and an SEO critic, let's say content critic and an SEO critic agent. These agents will provide feedbacks and scores on your content. You should address their feedbacks and improve your content. Cool. Okay, so this is our system message, and I should also define an LLM, an underlying model for this agent. So model client, I need to define that. Let's call it model for now. So just like what we've done in previous videos, I can import ChatGPT here. I mean OpenAI O3 Mini, more specifically. So from AutoGen from AutoGen x.models.openai import OpenAI chat completion client. And now I need to define the model. Model is an OpenAI chat completion client. The specific model will be O3 mini, and I need to provide an API key. The API key I have the API key in api.text, so let's read it. Open api.text. Read it and make sure there's no extra space at the end. And if you don't have your API key, you can easily go to platform.openai.com, and here you can go to the settings, and here's the API keys. You can create new secret keys or API keys. Once you create them, you can copy them. I recommend having it in a separate file. Never ever hard copy it inside your code. And make sure you don't push the API in GitHub, or you don't make it public. So here's our model, and here's our model client. So this is our writer agent. This is exactly what we used to do in previous videos, but in those videos we were going to make a round-robin group chat, and this is enough for a round-robin group chat. But the way we're gonna develop this project today, we'll be using a selector group chat. And let me show you what is a selector group chat. We can go to AutoGen documentation in the teams, and yes, here's the selector group chat. So it has a very good tutorial. I recommend you reading the whole page. It's not that long. So, okay, this is how it works. You have a bunch of agents, but unlike the round-robin group chat, in round-robin group chat, everything was deterministic. You know beforehand which agent is going to talk when. So let's say you have 3 agents, A, B, C. In a round-robin group chat, this is exactly the way they're going to speak. First A, then B, then C. Again, A, B, C, A, B, C, and so on and so forth. So this is a round-robin group chat. Of course, round-robin group chat is a very effective way of creating a team of agents, and you can actually cast many real-world applications to work in this way. But at the same time, there are many different real-world examples that, it is not inherently deterministic. You don't know beforehand which agent is going to talk when. So let's say, for example, in our example, the writer comes up with a piece of text, and then the content critic is unhappy about it. Maybe they need to go on several iterations before passing, a satisfactory piece of text to the SEO critic agent. So in this way, we don't know beforehand when is, for example, the SEO critic agent gonna talk. So this is how the selector group chat can help. We have a bunch of agents. We make a team out of them. And here's what happens exactly in these 4 steps. As you can see here, the team analyzes the current conversation context, including the conversation history and participant names and description attributes. So from here, we can see we need to also define the description for each agent. And this is different from the system message. To determine the next speaker using a model. So we should also have a model to determine the next speaker. By default, the team will not select the same speaker consecutively unless it is the only agent available. This can be changed by setting this flag. You can also override the model by providing a custom selection function. And this was the first step. So in the first step, the team analyzes, okay, who's gonna speak next using a model, an LLM. And in step 2, the team prompts the selected speaker agent to provide a response, which is then broadcasted to all other participants. In other words, then the agent that is selected in the first step is gonna talk and before talking, before generating the output, it will see the whole previous chat history. And in the third step, the termination condition is checked to determine if the conversation should end. If not, the process repeats from step 1. So we will check a termination condition. Maybe we terminate the chat. Maybe we just go back to step 1. Again, we decide who's going to talk next. And then that agent will talk. And again, we will check for the termination condition. And as the fourth step, if the termination condition is met, when the conversation ends, the team returns the task result. This is a class in AutoGen containing the conversation history from this task. Now we know that we should also specify a description for each agent. Let's go and do it. So other than a system message, I should also add a description for my agent, a writer agent that writes content based on a given topic. Yeah, fair enough. So this is my writer agent. Now it's time to define the content critic agent. Content critic agent. This is also an assistant agent. The name is content critic agent. By the way, if you have GitHub Copilot, it is really useful in this context that you need to repeat a pattern that you already have it several times. Very good suggestions. Description, a content critic agent that provides feedback on the content written by the writer. Cool, by the writer agent. And here's the system message. You are a content critic agent. You will be given a piece of content, or let's say text, and you need to provide scores on the grammar, clarity, and style of the text. You should also, and let's also set the range for the score to provide scores from 0 to 10. Yeah, on the grammar, clarity, and style of the text. You should also provide a to-do list of improvements for the writer agent to improve the text. And just according to my experience, this content critic agent, might have a tendency to rewrite the text itself. I don't want it to do that. So let's explicitly state that you should never write the text yourself. Cool. Okay. So this is the system message. The model client is just the model, and I guess we're good to go. And now a similar process for the SEO critic agent. So the name is SEO critic. This is the description, an SEO critic agent that provides feedback on the SEO of the content written by the writer agent. Cool. And here's the system message. You are an SEO critic agent. You will be given a piece of text and you need to provide scores from 0, just a single score. Provide a single score from 0 to 10 on the SEO of the text. You should also provide a to-do list of improvements for the writer agent to improve it. And exactly, you should never write the text yourself. And just according to my experience, I will add this one as well. Be as specific as possible for both of these agents be as specific as possible. I don't want it to just say something in general. I want it to be specific about that piece of text. Okay, and the model client will be just the model, and we're good to go. I also need to define, there are two ways actually. Let me show you. One way is that I can just define the selector group chat right now with no specific prompt on how to choose the next agent at each stage. Let me show you the base code for selector group chat. This is the selector group chat, and as I've said this several times in previous videos, this is a very important skill to be able to skim the documentation or the GitHub code and find out the answers to your questions. This is so important. So even if you already know the answers to some of your questions, this is a very good idea to just practice going to their documentation or their GitHub codes and find out the answers there. So this is the code for selector group chat. And let's see. Okay, you can see in the constructor of this class, we have a selector prompt, and this is the default prompt for the LLM responsible to choose the next speaker. You are in a role-play game. This is not exactly what we're doing now. The following roles are available, and this is the roles variable. Then, inside the code, they will format this string and they will replace these with, the actual content. Read the following conversation, then select the next role from participants to play. Only return the role. And this is the history. Read the above conversation. You see, they're repeating it because they know that the LLMs aren't that smart right now. We need to repeat something several times, maybe using different languages in different parts of our prompts to make sure they will follow our instruction. Read the above conversation, then select the next role from participants to play. Only return the role. This is good, but we can improve it and tailor it for our current project. So let me just copy it. So I need to specify selector prompt. Let me do it this way. Okay, you are in a role play? No. You are in a team of content generation agents. The following roles are available. These are the roles. Read the following conversation. Then select the next role from participants to play. No. From participants to speak. Only return the role. And this is the history. And read the above conversation. Then select the next role from participants to play. No. To speak. Okay. Now I would also add this. If a critic agent has some to-do list for the writer agent, the writer agent should address it in the next message, and that same critic agent should revise the text or should review the writer agent's message afterwards. Okay. let's see. And now it's time to define the selector group chat. So let me import it as well. From AutoGen agent chat.themes, import selector group chat. So here's the theme, a selector group chat, and well, the team gets a list of participants. So they will be writer agent, content critic agent, and SEO critic agent, and also a selector prompt, which we've already defined. And we should also pass a termination condition, because I don't want the conversation to go on and on until, till the infinity. I need to stop it somewhere. So for now, I will use a pre-built termination condition. I will call it termination. Let's define it. But as one of the next steps, we will define a custom termination function. So from AutoGen agent chat.conditions, import text mention termination, let's say. And also I can say we have this max message termination as well. We can specify, okay, if the number of messages has reached to, let's say, 10, then terminate it, no matter what. But here I can specify a condition for the writer agent. I can say, if both of the critic agents give you a score, give you a minimum score of, let's say, 9 in all of the scores, you should regenerate the content, and then you should exactly say, terminate. So this way I can inspect the final output of the writer agent, and if there is the terminate expression, I will terminate the conversation. Okay, so let's define this termination. This is the termination. It is a text mention termination. I should also specify what text to mention. If terminate is mentioned, then terminate the conversation. I can also concatenate another termination condition, which will be the max message termination. And I can say, okay, if the number of messages became, let's say, 15, then stop the conversation. So here's the team, and now we're ready to orchestrate the team. For now, since we're working in terminal, we've not yet started to develop the web application. I can also use the console object in AutoGen. So it helps me to visualize the chat way better. So let's say from AutoGen core.ui, or AutoGen agent chat, I guess. AutoGen agent chat.ui, import console. And here I can say await console. It's a coroutine, so await console. And then I need, it gets a stream, which is an async generator. So I can I can call the run stream method of my team. So let's say team dot run stream, and I need to specify the task. What is the task? It can be a string as well. So task will be, for now, let's say, write a short paragraph about the importance of AI in modern technology. And this is the task. Okay, let's create an event loop and run this coroutine to see how it behaves. Python writer.py. Okay, we can see the errors. Selector group chat, its constructor is missing one required positional argument, which is the model client. Fair enough. I forgot to specify what model client to be used in the selector group chat. So let's say it gets a model client as well, because this model client, this LLM, is responsible to choose who speaks next. And I will use the same OpenAI O3 Mini for this model client as well. Okay, we can see the team has started. Here's my task. Write a short paragraph about the importance of AI in modern technology. This is the writer agent. It says, AI has become a cornerstone of modern technology, blah, blah, blah. And here's the content critic agent. The grammar is 10, clarity is 10, style is 9. Here's some to-do task. And then here's the writer agent. It has addressed the task specified by the content critic agent. So now all of it is 10 out of 10, but you can see the bottlenecks and the challenges in a real project development. You see, although the grammar, the clarity, and the style scores are all 10 out of 10, we still have some to-do lists, and these two agents are now continuing while it's not necessary. So, if they're 10, then we don't need any to-do list. I should also explicitly state this on the system message of the content critic agent. And the writer agent has addressed those as well. Now we have the SEO critic agent, 9 out of 10, with some considerations, with some to-do list. Now we can see the writer agent has addressed these to-do list. You see it has wrapped it in HTML. Now we had some headings, some paragraphs, and this is the most recent version of our text. And then the writer agent has also generated terminate, which caused the conversation to terminate. So let's improve it a little bit. First of all, for both of the critic agents, I also need to specify that, let's say, if for the content critic, if the minimum score of the text is, let's say, 9 or above 9, leave the to-do list empty. Yes. And a similar statement for the SEO critic. If the minimum score, or it's just one score, so if the score of the text is 9 or above 9, leave the to-do list empty. And let's see if it behaves better now. Let me clear it to avoid confusion, and now. Okay, here's the writer agent's message. Okay, good. All of it is 10 out of 10, and to-do list is none. Cool. But for the SEO critic agent, you see the score is 8. We have some to-do list to improve the current version. And just like the previous run, it has wrapped it in HTML script now. Now it's 9 and no to-do list. So I guess the writer agent will, and very wisely, even after the SEO has, given a score of 9, the conversation has gone to the content critic. It's again 10. So now the writer agent comes up with the most recent version and says terminate. Okay, this is good. So what to do next? Well, first of all, just as a little bit of development challenge, although it is working now, it's fine. We can start developing the web application right now. But as I mentioned earlier, both of these critic agents, the content critic agent and the SEO critic agent, their outputs are just a string, a piece of text. Although, according to my system message, they're saying, okay, this is grammar, this is clarity, this is style, and then this is the to-do list. But I have no control over, the order that these appear. Maybe in another run, maybe if I run this 10 times, maybe clarity comes first, or maybe the to-do list comes first, or maybe instead of to-do list, it just says to-do and then colon. So I have no control over this one. And a better way to do this, since these different fields are specified by the developer or by us as project managers, let's say, we can define custom data types using Pydantic. This is a very standard way of doing this to validating and also defining custom data types. I can define a new data type using Pydantic, and that data type has a grammar, which is an integer, a clarity, a style. These are all integers, and also a to-do, which might be a string. So let me import Pydantic as well. Import Pydantic. And from Pydantic, import base model. This is a very common class that we use to define new data types. So I would say class content feedback. It inherits from base model, and yeah, these are almost true. The grammar will be an integer, then we have the clarity, it will be an integer, then we have the style, an integer, and a to-do, which will be a string. Okay. And similarly, I will define a class of SEO feedback. Again, it inherits from the base model. It has an SEO score, which is an integer, and a to-do, which is a string. So now for these two critic agents, for the content critic, I can also specify output content type, which will be the content feedback, and also let me see this one. Yeah, for the SEO critic agent, I will also specify output content type, which will be SEO feedback. Let me run the code again. Okay, you can see it now. Now we have a structured message for the content critic agent. Here's the grammar, here's the clarity, here's the style, and here's the to-do. And since all of them are 10 out of 10, we have no to-do. Okay. And again, likewise, we have a structured message for the SEO feedback. The score is 7. We have a bunch of to-do, and then we have the writer's response, and then we have, again, SEO feedback. the content critic agent is still giving 10 out of 10 for these 3 items. And this is the final answer. So this is a much better version of our initial draft or our initial text. It is both, high quality from the content aspect and also from the SEO aspect. And because the writer agent generated this terminate, we're terminating our condition. Okay, but let's think of this in a larger scale. So, right now it's totally fine. The pipeline, the project is working, the agents are collaborating, and we have a final answer. And by the way, this is just a proof of concept. So, and the LLMs for such usage, for just testing it on 1 or 2 or let's say 10 different test cases, they're almost free. There's no cost, no particular cost. But imagine you have a company and you have thousands or even millions of users. So this single message, if you imagine that, okay, in the end you want to rewrite, the final output, and you want to do it 1,000,000 times a day, this is a very, non-negligible cost. You should save it. So we should look for a better way to terminate the conversation instead of repeating it. And also right now we have no way but to trust the LLMs. We've specified it in the system message of the writer agent that, okay, if all of your scores are 9 or above 9, then just say terminate. But who knows, maybe in one of the runs out of 1,000,000 run or 1,000 run, or maybe the rate is even larger than 1 in 1,000. But maybe in some of, the runs, in some of those executions, the LLM does something else. We can never, trust it blindly. So whenever we can do something inside the code and, we have a better guarantee of doing it, why not? Okay, so instead of having these 2 different termination conditions, the text mention terminate and max message termination of 15, meaning that, okay, when we have 15 different messages in the conversation, terminated whatsoever. But we can define a custom termination condition that inspects the conversation and finds out if both of the critic agents have a minimum, score of 9 out of 10 or 8 out of 10, or, even that might be a parameter for that termination condition, then we will terminate the condition, the chat. Okay, so there is also a very good piece of documentation in AutoGen website. You can go to termination, I guess, and it's almost here. Yeah, this is how, this is a very good section on how to define a custom termination condition. Let's take a quick look together. Okay, first of all, we need to define a custom data type, a custom class for the configuration of that termination condition. Well, obviously, different termination conditions can have different configurations. For example, just as I said right now, in our example, in our project, one configuration is that, okay, what is the threshold? What is the minimum score that we want to terminate a condition? This is a part of our configuration. So we should specify something similar. And then here's our custom termination condition class. It should inherit from both termination condition class and component class. And what is a component class? How can it help? It helps us to, we can make it happen even without this component, But having this, then we can serialize, or concatenate different termination conditions, just as we did it here. You see I have this character, and these two different termination conditions are concatenated or serialized. We can do the same if we inherit from component. So, well, obviously we need to define the constructor, and we have a property for this class, terminated. We need a member variable to track if the termination condition has happened or not. And then we need to define the call method in an asynchronous way. We need to define a call coroutine, more precisely speaking. And it gets a sequence of messages at that moment. We'll see how it works inside the code momentarily. And then, we should implement our logic here. And in the end, if the termination condition is met, we should set this member variable to true, and we should return a stop message. This is a predefined class in AutoGen. We can specify a content and the source, and otherwise, if the termination condition is not met, we return none. We should also define the reset. We should also define the reset and the toConfig for, because we want to also be able to save our current configuration and also to load it. So we should also define a class method from config. If you don't know what this is, don't worry, it's just a decorator. And if you don't know what is a decorator, again, don't worry, you can go on without knowing this stuff, but it is a very good idea to go and read about them. They're not complicated. This essentially tells the Python that, this is a class method, not an instance method. So when we're gonna call it, we can call it, using a function called termination dot instead of an object dot. So this is just a difference for those who know a little bit about this stuff. And that's it. That's how we will develop a custom termination function. Okay, let's do it together. Just out of laziness, let me just copy these imports. Well, I need this one, I need this one, I don't need this one, and also this one, and also this one. Okay, I guess this is good now. So let's define the custom termination condition. I would say, okay, let's name our class score termination. And I also need to define the config. So let's do that right now. Class score termination config. It inherits from base model, and it has a mean score trash. This is a better name, I guess. And it will be an integer. Okay. And now I will define the score termination condition. And as we saw earlier, it inherits from the termination condition class and from the component. And we should also pass this custom config class, score termination config. Config. Yes. Okay, let's define the constructor. It gets the mean score trash, which will be an integer, and I will set the default value to be 8 because I don't want to be super strict right now. And I will just make sure I have access to this one. I define an instance variable for this one. Self.mean score trash will be mean score trash. Okay. And now let's see. I need to define the terminated as a class property. And so I also need to define a terminated variable, a flag to just track if the termination condition is already met or not. So terminated, it will be false initially. And now a class property, terminated. Was that terminated? Right. And this is just for documentation. It returns a bool. It returns self.terminate. Okay. And now it's time to define this coroutine. So let me copy this and then we'll start from this. Okay, so we have a messages. I don't need this stuff. These are just for documentation. Of course, I encourage you to keep them and do the imports, but let's not do that right now. And in the end, it gives us a stop message, or it can return none. Initially, if the condition is met, we need to raise this exception that termination condition has already been reached. Fair enough. And then for message in messages, this part is a little bit tricky. This messages is not actually the whole chat conversation, the chat history. You know, in AutoGen, an agent can also call a tool, get the result of a tool, and then reflect on the output. So these will be different messages in that specific turn. So, well, in a normal situation, in normal conditions, the agent just in each turn it has a single message. So these messages will just be a sequence or a list with just one message, one text message in AutoGen. But if the agent can also call a tool and does that, for calling a tool, we have a separate kind of message. For the result of that tool call, we have another message. And if we've allowed the agent to reflect on the tool output, we will have another text message afterwards. So that will be, for example, 3 different messages in a single turn. So just a heads up, this is just the messages in that turn for that agent, not the whole chat history. Okay, so just saying this, I need to specify some instance variables to keep track of the minimum, the latest minimum score for the content critic and the latest minimum score for the SEO critic agents. So self.mean critic score, mean content score, let's say. I initialize it with 0, and self.mean SEO score, I also initialize this as 0. Okay, so now I have to check if the message that I'm inspecting now at this stage is from the content critic agent. Then, I have 3 different scores, and then I need to look at each and every of those scores, find out what is the minimum of them, and then update my mean content score instance variable. So now I can say if each message has a source in AutoGen, we know that. So if the source is content critic agent, okay, then I can say that self.mean content score is the minimum of, okay, message, fair enough, message.content, if we had done this like the previous videos, message.content would have been the text that the agent generates. But now we have a structured output. We have these different custom data types, content feedback, SEO feedback, and they have different keys, grammar, clarity, style to do, SEO score to do. So I can directly point out to them and get their value. So message.content.grammar, message.content.clarity, clarity and message.content.style. So this will be the self.mean content score. Okay, so this is this one. And I should do a similar checking for the SEO critic agent. In that context, it's clear we have just one score. We don't need to find out the minimum out of a bunch of scores. So self.mean and SEO score. I don't even need to use mean in its name, just SEO score. Also for this one as well, SEO score. So self.SEO score will be message.content.SEO score. Is that right? Yeah, SEO score. Just to mirror the pattern for my naming, I can also say grammar score, clarity score, and style score. And I need to update these as well. Okay. Now, in each turn, I'm checking, where is this message coming from? If it's from one of the critic agents, I'm updating the variables responsible for the minimum or for the score of those agents. And now I need to check if the minimum value of, if both these scores are, mean critic score and the SEO score are both above or equal a threshold, then I can terminate the message. But I should do this out of the for loop. So once I've inspected, then I can say here's the condition. If self.mean content score is greater than or equal to self.mean score trash, and self.score is greater than or equal to mean score trash, then self.terminated will be true, and return a stop message. Say the content will be the minimum scores are above or are greater than or equal to the threshold, and the threshold will be self.mean score trash. Okay. And the source will be score termination. And then, similar to what we saw in this documentation, I need to also specify the reset and the toConfig and this class method from config. So let me copy them as well. Well, this is for resetting this termination condition. This is for saving it, and it will, we have this toConfig method, and it will give us score termination config, and we will return score termination config, and its mean score trash will be self.mean score trash from this instance. And for this class method, it gets a config, the output of this toConfig method, and it will be score termination config, and it will return this class, a new instance of this class, and the parameter, the mean score trash, will be config.mean score trash. Okay. So I guess everything is cool now. And now I can pass this custom termination condition to the team instead of the previous termination. I can even keep these as well, but for now, let's get rid of this one. I can create a custom object from my new class. Score termination condition. And the mean score thresh will be, let's say, 8. Okay. Let's run and see if everything's all right. Okay, the content critic agent is giving us 10 out of 10 for all of those items, and this is the score of the SEO critic. It's 8, so it's equal to our threshold, and you see it instantly terminated our conversation. So it's working. And now we're good to start the web application. It will be just like our previous videos. And by the way, if you have an interesting idea for the next videos, some cool agentic projects, please don't hesitate to leave a comment for me. And my goal is to have a playlist of exciting agentic AI projects. I would like to teach anyone who is interested how to develop these projects. This is a very important skill for the future. So don't hesitate to tell me your opinion or tell me your ideas, and I will definitely record some videos for the interesting ideas. So let's create the app.py. Let's import Streamlit just the way we did in the previous videos. And again, we need to import async.io as well, because our agentic side is working using coroutines. So we need to create event loops here as well. And from writer, okay. So one thing we still need to do, we need to, right now in the writer.py, although it's working, it's a standalone code, but everything is happening really in this main coroutine. So let's split that into 2 coroutines. I will have a team config coroutine, and let's also specify the mean score thresh here. So this is how I will create the agents and the teams inside this function. I will move from the beginning of the main coroutine until, let's say, here. So now we have a team config function. It gets the mean score thresh, the minimum amount of score that is needed to terminate the conversation. I also need to modify a little bit these system messages. For example, here, if both of the critic agents give you a minimum score of, okay, now this will be a variable, mean score thresh. In all of the scores, you should regenerate the content. Okay. And again, for this one, if the minimum score of the text, and this is mean score thresh, or above the mean score thresh, we'll just leave the to-do list empty. The same goes on here. If the score of the text is mean score thresh or above it, mean score thresh, then leave the to-do list blank. And that's it. And in the end, it should return the team. And then I will define a new coroutine. I will call it orchestrate. It gets a team and a task. And here's what happens. So instead of using this console, this is just for the sake of visualizing the chats in the terminal. We should do it just like our previous videos. We should create an async generator, and we should yield each message once we have it. And then we need to call this generator from our UI to get the messages the same instant that we have them. Okay. So I would say async for, we need to iterate over this team.runStream for message in team.runStream, and the task will be the task. Okay, now we have different kinds of messages, because for the writer, well, first of all, for each message we should specify the source of that message in the beginning. This helps us to differentiate between messages from different agents inside our UI. Because I want to just return yield some strings in this orchestrate. I don't want to, mess with different types, different classes in AutoGen in my UI. I just want to yield a string here and get it inside the UI. So I would say if message.source is writer agent, then print, this one. This is fair. Message.source and colon, and then message.content. And this will print it in the terminal. I will call it message, and then I will also yield message. And then I would say else if message.source was content critic agent, then I want this message, message.source colon, this will be content critic agent colon actually, and then I would say message.content.grammar score, let's say grammar score, and then I will have style score, and then clarity score, and then to-do list, to-do. This is the way I would like to show this message. And in a similar manner for the SEO critic, I would say do it this way and yield the message. Okay, one other way, this is, using this way, I can customize. Maybe I would like to make some part bold, or maybe I wanted them to appear in different lines. But another approach was that, just saying message score and message content, just like the way we did with the writer agent. Let's see both of these. Okay. So right now, for the SEO, I'm deciding on the format of the message. But for the content critic, I am just, returning the message content, which is, the same data type I defined earlier, this data type. But how they appear as a string, I have no control over that right now. And let's see how it looks. So inside my main here, I will have a main coroutine as well here, because I want this script to be standalone. I want to be able to run this script alone without, depending on the UI part. So this is my task. And then I will say team is team config with min score thresh of 8. And then I need to iterate over the orchestrate async generator. And I don't need to do anything because I'm already printing it. So I will just pass. let's clear and let's execute writer.py to see how it looks. Oh, just let me stop it because it will spit some mess now. I also need to have some dashes to make sure it's clear that different agents are sending different messages. So this is from the writer agent. You can see the paragraph. And this is from the content critic agent. Oh, and yes, we have an error because after the chat is over, the conversation is over, it will return a task result object. And it is saying that task result object has no source. So why is this happening? Let's see. This is happening for this part if message the source equals this one and this one. So, the messages are coming here, I'm iterating over different messages. Some of them are from, almost all of them but one are from different agents, so it's fine. But as the last message, this will not be a real text message. This will be a task result object. And the task result object does not have a source. So one way is that I can, have an outer if checking that if these messages are text message, then do this. So I can say, let's import text message as well, because all of these are text message. And let's see. Or one other way to do this is that I can check if it is not a task result object, then do this. Let me import the task result object. This is another way. I can say from AutoGen agent chat.base import task result. And then here I can say if message, actually if not, is instance message and task result. If message is not an instance of task result, then do this. Okay. So now this is the writer agent. This is the content critic agent. And this is the SEO critic agent. The score is 7. It's smaller than the threshold, so the chat will go on and okay, now the SEO score is 9 and the chat is terminated. So we're good to go now. We can continue the app.py. So from writer, import team config and orchestrate. And so initially I want to set a title for my application. Let's call it agentic content generation. Yeah, something like this. And then I would like to have a container to display the ongoing chat. So I will call it chat. It will be an st.container. And I would like to enter my desired text not as a text input, but as a chat input. So I would say prompt will be st.chat input, and here's the placeholder. I would say enter your prompt here, yeah, or enter a description of the content you want the team of agents to generate, yeah. And if I have a prompt, so if prompt, then for now, just to show you how this works, I would just very easily say with chat st.write, hey, just this one. And to run the Streamlit app, I would say Streamlit run app.py. It doesn't work with Python app.py. So here you can see this is my title, this is my chat message, chat input object, chat input element, and whatever prompt I say, I will have the hey here. So now I only need to import my agentic side in this if condition, in this if statement. So I would say with chat, or let's remove this for now. I need to, because the writer.py is almost working in, using async IO, and I have a coroutine for orchestrate. This is not an ordinary function. This is a coroutine. I need to create an event loop here. So let's define a coroutine here to show the messages. So I would call it main. And inside the main, I would define the team. Here's the team and the mean score threshold. For now, let's say 8, but then we'll also have an element for this as well. And I need to iterate over this async IO generator. So async for message in orchestrate of team and prompt. And now I can say, and I want to do it inside the chat container. So with chat, I will iterate, and I can say, okay, I want different agents messages to be appeared with different avatars, but for now, let's say all of them having the same avatar, but then I will generate some avatars for them as well. So I would say if message dot starts with, if this is from the writer agent, starts with writer agent, then I would like an st dot chat message. The name will be AI. This is a predefined name, and it has a predefined avatar as well. So for this one, I will display it and I will render it as a markdown. And for now, let's display all of the message. I want to make sure everything's all right, but then I will remove this part, before colon, writer agent colon. I will remove this one. And similarly, if this message is from the content critic, do it this way. Maybe instead of AI, I would say human, because it has a different avatar for now. And I will use markdown for this as well. And then if this is from SEO critic agent, again, display it like this. And then I need to define an event loop and run it. And even before doing so, I can say with sc.spinner, I want to convey this that the agents are working. So let's say agents are heavily working. Yeah. And this is the event loop, and then after the event loop is executed, I would say sc.success done. Okay, so I guess everything is all right now. We can run the app to see how it behaves. Streamlit run app.py. And now I would say write a short paragraph about Lionel Messi. Okay, right now we're seeing one, I can say bug or one downside of this application. I cannot see my own message. I need to do that as well. But you see, Lionel Messi, renowned as one of the greatest footballers of all time, to me, he is the greatest, not one of the greatest, but has mesmerized fans worldwide and blah, blah, blah. Okay. Here's the content critic agent. All of the scores are 10, and then here's the SEO critic agent. The score is 8, so we're done. Okay, let's make it a little bit more beautiful. This UI is not at its best shape right now. So, first of all, let's display this content critic agent and SEO critic agent messages a little bit more appropriate. So I need to change the string that they're yielding here. Well, I'm rendering them as markdown, so I can use, bold. I can make some part bold or, some part italic. So I would say for the content critic, instead of yielding the message this way, I can say, okay, this is from content critic, and I can make it bold. These double asterisks make it bold in markdown, content critic. And for the grammar score, it will be like this. And let me have an enter. To have an enter in markdown, we need 2\n, and then I can just remove this so that Copilot suggests me the correct way. Yeah, now it's just doing it for me. Oh, and I need to have these enters here as well. Here, and also an enter here, and one here. Okay, I need to do a similar thing for the SEO critic now. So here's the SEO critic message, and here's the SEO score, here's the to-do, and I guess we're good now. I also want to display the user's message, so I need to add a new condition here. If the source is user, then do it this way, say it's user. And a very good suggestion by Copilot, if it's from score termination, because as you can remember, inside my custom termination condition, I specified the source as score termination. Whenever I'm terminating the conversation, I'm yielding a stop message, and I'm specifying its source as score termination. So I will also generate that as well. So this is how it works. And now I can add these two elif clauses. Elif message that starts with user, then do it this way. And elif it starts with score termination, just do it this way. And termination is not a correct predefined name for the chat message. Okay, let's do it once more. Now I'm hoping for a much beautiful response. Write a short paragraph about AI applications in medical science, let's say. Okay, agents are heavily working. I still cannot see my own message. This is not good. Here's the writer agent. Oh, I forgot to modify the writer agent as well, but let's see if the critic agent's responses are displayed better. Oh, now we have a problem. Let's see. Oh, okay. Fair enough. So now we have, a bold version of content critic and, SEO critic. And inside the app, we're checking for this kind of message. So I need to check for the appropriate version as well. This will be writer. And this will be content critic this way. And this will be SEO critic. It was a good suggestion. And this will be user this way. And score termination this way, or termination this way. Okay, let's see. Let's see here. Oh, it should, for these two, this is user, this is termination. Okay, fine. Let's check again. Write 2 paragraphs on Lionel Messi's contributions to AI. Funny thing, let's see what we get. Now we have the user's message here. Okay, here's the grammar score, the clarity score, style score. To do is empty, and now we have the SEO critic. The SEO score is 8, and we're done. Oh, but we didn't display the termination condition. And I guess, yeah, that's fair because the termination condition will be on the task result, not as a separate message. One way is that I can also, check for the task result object and find out the termination message there. I can do it right now, or I can leave it to yourself, but let's do it. Yeah, let's do it. So I can say, if it's not an instance of, okay, let's say it this way. If it's an instance of task result, do this. Else, we have these statements. And now I have print message that we have this stop reason, for the stopping. So I will define this as message, and I will yell this MSG. Clear, and let's run it again. And I can say, before this, I can say termination. Yeah. I suppose this should work now. Let's see. Okay, write a short paragraph on how AI is causing, let's say, climate change this time. Okay. This is the user's message. Oh, wrong behavior. And how are they giving scores? I don't know. Let's see. Yeah, we have the writer agent, so we're just not displaying it correctly. And why is that happening? Let's check. Inside the writer.py, there must be something wrong here. So I say, if this is an instance of task result, then do it this way. Else, if it's not an instance, do it this way. Oh, yeah, I should also make it like writer in bold, because the UI is looking for this one. Inside the app, you see, we're checking if the message starts with this one. Okay, and now we have the termination message. It says the minimum scores are greater than or equal to the threshold 8. Fair enough. Okay, so it seems that we're getting close to the end of the video. Just right now, the current version of the project has 2 bugs. I can't say 2 bugs, but let me show you what I mean. Streamlit run app.py. Now I would say write a short paragraph on Lionel Messi. Okay. This is the user's message. We have a piece of text. This is the critic feedback. And this is the SEO critic feedback and the termination. Everything seems fine, but now I want to continue the chat. I would like to say, now generate another paragraph on his most famous rival. Let's see what happens. We'll have 2 problems now. First of all, you see something's happening here. And this one has been overwritten. It starts from here and it is clearing the previous chats. It is, removing them. And let's see the generated text. His most famous rival emerged as more than just a competitor. It is generating nonsense. It doesn't know who it is talking about. So the problem is that we have 2 problems now. First of all, we didn't, keep the previous chats. We want to do that as well. We want to keep or retain whatever chat we have, whatever history we have. And then, and more importantly, it didn't even remember what we were talking about. Well, as developers, the reason is clear to us, because every time we have a new prompt in the app, you see, we're creating a new team. Well, this team has no clue what has happened before its creation. So we should somehow, save the state of that team and load it again once we have a new team, to make sure the team knows what was happening beforehand. Okay, so in order to keep the chats in the UI and not cleaning them, not removing all of them, not clearing them, I can have a session state in Streamlit. The logic for Streamlit is like, whenever there is a new event on the web application, whenever you click on a button or something, you write down a prompt and press enter, everything from, it comes to this code and it starts from the top and it executes all of the code until the end. So that's why we don't keep the previous chats. So to tackle this problem, Streamlit has some session state. We can keep some of the important states of the application in session state. So Streamlit makes sure that these session states, these variables, these keys in the session state are kept and not reinitialized once an event has occurred in the web application. So I can check initially, even before setting the title, I can say if messages is not in st.session state, then create an empty list and call it messages. And then here I can have a function to display the previous messages whenever I'm rendering the page again, the UI again. So I can say def show messages, and it gets the chat container. Just like what we've done here, I need to redo it here as well. For I in, or I can say for message in st.session_state.messages, and correct suggestion, I believe, it is checking for the source of each message and rendering them. Okay, cool. And once I have this chat container, I can call this show message method. So show message with chat. This way my previous chat will be kept even if I have a new event. And the only thing I need to do is that once the agents are working, are collaborating, and I have a new message, I need to add that message, append it to the messages session state list. So I would say, for each message, st.session_state.messages, append the message. Okay, so this way I have, I can keep the previous chats in the UI, but to make sure that, in reality, under the hood, the agents have also access to the previous context, the previous chat, I need to keep the status of the team as another session state. And if I have a session state, I need to load it before, orchestrating the team. So here I can say, after everything is done, after this async4, it's here. So I can say st.session_state.team state will be await team.save state. Yeah, we have this coroutine. And then once I'm creating the team, I need to check if team state is in st.session state, then await team.load state using the team state. Okay. Now let's see if everything is all right. I would say generate a short paragraph on Lionel Messi. Okay. we have the content critic feedback, the SEO critic feedback. The chat is terminated since all of the scores are equal or greater than 8. Now I can say write a short paragraph about his most famous rival. Okay. Now you can see, my previous chat is preserved, although it is not rendered correctly. Something must have happened. I need to check it as well. But at least we can see it is there, and we'll fix it momentarily. But now the agents are working, and my expectation is that they should generate something about Cristiano Ronaldo. Yes, you see. So the agents have also access to the history of the chat. So I guess something's wrong with my show message. Let's see. Exactly, something's wrong with it. So I need to, let me just copy and paste this whole part. Because, here in my if prompt, here I'm visualizing the chats, I'm displaying them as sd.chat message, but the GitHub Copilot suggestion wasn't using chat message. This is a downside of, trusting trusting Copilot suggestions blindly. And I need to do all of them inside chat. So this way, I guess everything will be fine. And the only remaining thing is that I want the user to decide the minimum threshold for the scores. So maybe after the title, I want a selector object, maybe a drop-down list or some other kind of selector object to choose the threshold. So let's say mean thresh will be sd.slider, or maybe what other choices do I have? We have select slider, I guess, or select box. And the label will be select the minimum score threshold to stop the agents. Yeah. Let's do it here. And then here's the options from 0 to 10, or a better way of saying this is that list of range from range of 11. Yeah. And the default value, let's set it to 8. So I want it to be 9. The index will be 9. And I guess that's it. So now I can say, inside my team creation here, instead of saying mean score thresh will be 8, I would say mean score thresh will be mean thresh. Yeah. So let's see. Okay. Select the minimum score threshold to stop the agents. So we have different options. I would say, let's say 7 here to be super easygoing. And now I can say write 3 paragraphs about Messi and his most famous rival. Yeah, we have 3 paragraphs now. One of them about Messi, the other one about Ronaldo, and the third one about their rivalry. And this is the content critic scores, and this is the SEO critic score, and this is the termination message. Oh, we have a bug here. you see the termination message. The minimum scores are greater than or equal to the threshold 8, but the threshold is not really 8. So how can we fix this one? Well, let's see. Obviously, when creating the theme, we're passing the true threshold, so that is fine. But I guess something's wrong when we're defining, yeah, here you see, we've hard-coded 8 here. It shouldn't be like this. We have the mean score thresh for this reason, for this purpose. So it will be mean score thresh. And this will fix this bug as well. And the only thing one other step, to make this better is to, maybe I can also have different avatars for different agents. So let's just search the internet, a writer icon, something like that. Maybe this is good. Let me just download this. And then I can say a critic icon. Let's see what we have. This is cool. And then let's find another icon as well. Let's say SEO icon, if we have something like that. Yeah, SEO. Or this one. Save it to downloads as well. Okay, I will make an images folder and I will copy them inside this folder. I'll call this writer. This one will be content and this one will be SEO. And all of them are PNGs. So inside my code in app.py, I can say, whenever I'm rendering their messages here, for the writer, I can also choose the avatar and I can point it to images writer.png. And the same goes for the human, we're fine. For the user is fine. And for the content of content critic, I will also specify avatar images content.png. And for the SEO, and it's not human, it's AI. This is also AI, just to be clear. This is also SEO.png. And for the user, it's fine. I guess user is a predefined name. We can see, yeah, user, assistant, AI, human, these are predefined. And I need to do the same here as well. I could have a show message function to do this just once, not twice. I've done this in a previous video, but here, since we're just doing it twice, it's fine. So this is for the writer. We have this avatar. This is for the critic. It's AI, and this is the avatar. And this is for the SEO. Yes, here it is. Let's check it. And okay, my threshold will be 5. Write a short paragraph on Agentic AI. It's not a super clear description, but let's see what it gets. The user icon is this one. Okay, this is the writer. This is the content critic. Oh. So I've mistakenly passed the SEO icon for this one and the content for the SEO. Okay, I can fix this. So maybe I can change the file names. Yeah, this is the file names. The file names were wrong. This is content. This will be SEO. And just to practice a little bit of vibe coding. Of course, vibe coding doesn't need that kind of practice in that sense, but let me also ask Copilot to boost the UI. I can pass the app.py, and I can say make the appearance of this app way more beautiful and professional. Let's see what it does. Oh, it created a CSS, a separate CSS file for the style. And let's see what is changing. It's setting the page config. That's okay. Instead of the min trash, what it is doing. We have a banner image. I don't like that, but let's see. And we have a sidebar for the settings, and we're selecting the slider here with the minimum threshold here. And we're having a button. No, I don't like it this way. No, undo that. And also undo this file. I don't need it. Let's have another conversation. Improve the UI and make it much more beautiful and professional. Do not change the logic or flow. Just change the UI. Oh, I forgot to pass which code. I guess it can understand, but let's make it simpler for it. App.py. Okay. Again, setting page config, setting style for the whole page. And what else? Now we have a sidebar, we have a title for that, and we have the slider for in the sidebar. And okay. It's fine. Let's see how it looks. Let's keep this. Oh, this is much better, I guess. Now we have a slider for the minimum score threshold. And we have this sidebar. And let's say generate a short paragraph about about what? Let's say the impacts of AI on Lionel Messi. Okay. Agents are heavily working. This is the user. This is the writer. Content critic. And SEO. Yeah, the score is 7, so the writer should modify. Now we have some links as well, and the text is more structured. Now it's 9 and we're done. Okay. So I hope you enjoyed it. So we've started this agentic project from almost 0, and we've developed all the steps through here. You've seen, we had 2 different parts, the agentic side, the UI side, and we had different challenges, different bugs, but we did it in a very short time. I hope you enjoyed it. Feel free to give me your ideas for the next videos. And also, you see, although, we've done it in, I guess, almost 2 hours, but we had very good challenges, from both, development challenges and user experience challenges. And we tried to address each and every of them. So this is a very good exercise. You can do it yourself. Actually, I strongly recommend you to do it yourself. It can boost your agentic AI development skills a lot. And I hope you enjoyed this video. Until the next video, take care.